Alright, hey everyone, this video is about what's classified as the question with most points, question 36, 37. It's worth 6 points on the Regents. I consider them probably the hardest problem in your so-called Regents exam, right? The one you get. And today we're going to try to look at all the hardest Regents problems from June 16th to January 2026. So let's buckle down, let's tackle this, and make sure we know how to do all the problems, and that'll give us a great chance to pass, but better yet, to even get a good score in our Regents. All right, let's take a look at this problem. Drugs break down in the human body at different rates, therefore must be prescribed by doctors to carefully prevent complications such as overdosing. The breakdown of a drug is represented by the function n of t equals n sub 0 e to the minus rt, where nt is the normal amount left in where nt is the amount left in the body, and n sub 0 is the initial dosage. R is the decay rate, and t is the time in hours. Patient A, defined by A of t, right? So patient A, defined by A of t, is given 800 milligrams of a drug with a decay rate of 0.347. Patient B is given, defined by B of t, is given 400 milligrams of another drug. So again, that's the initial amount they take. Patient B, 400 milligrams with a decay rate of 0.231. All right, so let's look at the rest of the question, what they're asking. Write two functions, A of t and B of t, to represent the breakdown of the respective drugs given to the two patients. Now, this is very important. They define how to write your function. So you're not going to write f of x here. They can take a point off for that. You're not going to write y here. That's an equation. That's not a function, right? So you're not going to write either of those. What you're going to do is write A of t. That's how they want you to define it. A of t. So A of t, the initial amount is 800, right? Remember, this is the original equation, n0 e to the minus rt, where n0 is the initial amount. So I have here 800. That's the initial amount for patient A. Now I have my continuous function e, and I put in my decay rate. Remember, it's minus decay, right? So minus 0.347 t. Be careful. That's a t. That's supposed to be a t there, not an x, because they want to define by A of t. All right, now let's do patient B, which is B of t. Again, I'm going to be careful with the language. B of t equals 400, which is the initial value, e to the minus, let's look at the decay here, 0.231. So 0.231, again, t right here. They want it defined by t. All right, now we have that. That's great. Now they're asking us to graph each function on the set of axes below. All right, let's get to graphing. So this is the best thing you can do to graph. Let's break this down. I'm going to go to my graphing calculator. My graphing calculator right here. All right, so I already put in these functions earlier, right? So I have, clear this up. All right, let's clear this up. All right, so I'm going to redo it again. All right, what was A of t? A of t was 800 second ln, which gives e to the minus 0.347 t, or x, right? In our calculator, we're getting x and not t, right? But they're not going to see our calculator work. They're going to see the work on the paper. So we can write minus 0.347x. And then I'm going to go to y2. That's B of t. So B of t is going to be 400 second ln, which gives me e, minus 0.231 x, right? Now, I'm going to check my window here. Actually, I'm going to check my table, sorry. I'm going to check my table here. My highest amount here is 800, right? Look, I'm starting at 0, right? Because my x-axis starts at 0 because I'm counting by hours, right? That's time. So my x is 0. I can't go to negative time, so I'm going to start at 0 time, right? And I can't, and my output here, the highest one is 800. And you can see it keeps going down and down and down, down, so on and so forth. All right, so we can choose a set of things to, set of values to graph because they didn't define it. They didn't say, oh, graph from 0 to 5. They didn't say graph from 0 to 10, right? So we can choose. So I'm going to choose from, let's say, 0 to 8, all right? So I'm going to adjust my window that way. I'm going to go to my window, all right? So remember, my x, I'm going to start at 0. We're going to go all the way up to 8. I'm going to go to my y minimum. Remember, I'm starting at 0. I can't have a negative amount of the drug, right? And the maximum I'm going to do is 800 because 800 is the highest output I saw at my table. Then I'm going to click graph. All right, so as you can see, this is what the graph is supposed to look like when x, the time in hours, goes from 0 to 8. Now, the best thing to do while graphing, right, is to make sure you graph properly. You don't just want to write squiggly lines. Let me show you what I mean. You do, I see the basic graph. All right, so I'm just going to make some lines here. You know, they look nice, right? I'm just going to make it look like this and make this one look like this, right? And, okay, they'll be happy I graphed it, right? No one wants to see that. That's completely incorrect. You have to do it properly. The best way to do that is to look at the table. So let's find the table for a of t, right? Let's find the table for a of t. Remember, we're going from 0 to 8. So a of t, I'm going to write my x values, x comma y. Well, this is t, right? They want us to divide by t. So t comma y. I'm going to go from 0, 1, 2, 3, 4, 5, 6, 7, 8. And now I have to look at my y values. All right. I know I'm going to start at 800 at 0 hours. That's when I just take it. That one's easy. Now I'm going to write the rest of the values. Now you don't have to write like I am, but make sure you follow this method. So at 1 is 565. At 2 is 399. I'm just going to estimate here. 565, 399, right? I'm not going to write the decimals here. And at 3 and 4, I'm going to check again. 282, 199. So 282, 199. 5, 99, 70, 49. So I have 99, 70, 49. 99, 70, 49. One more. Let's go. All right, and at 8, it's 49. What did I miss? Okay, I missed at 5, right? So, again, do this properly, right? At 5 is 141. So 141, then it's 99, 70, and 49. All right. Now, I don't want you writing the table or making the dots for b of t already, right? You don't want to get confused. So let's do this properly. Let's scale our graph, right? So we're going to start at 0, right? And remember, we're going all the way up to 8. So every 2 spaces, I'm going to do 1. 1, 2, 3, 4, 5, 6, 7, 8. All right, this goes a little more. It is what it is, all right? We could do 9 and 10. Why not? Since it goes all the way here. Make it extra accurate. 9, 10. But let's make our indents. And then on the vertical axis, we have to go to 800. So maybe every 3, I'll do 100. 100. Hopefully this works. 200. All right. Sorry. 1, 2, 3. 1, 2, 3. 300. 1, 2, 3. 400. Well, it looks like it's not going to work out if I take every 3 spaces because I'm going to go above it. So I'm going to do every 2. So every 2, I'm going to do 100, 200, 300, 400, 500, 600, 700, 800. All right, now I'm going to graph this stuff out. All right, so let's get to graphing. At 0, my function here is 800, so I'm going to graph that. At 1, our 1, it decays to 565, so which is just a little under 600. At 2, it goes to 399, which is basically 400, so I'm going to make a dot here. At 3, it's 282, so a little bit below 300, so I'm going to make a dot here. At 4 is 199, which is basically 200. At 5 is 141, so a little below this line right here, right? Because this is supposed to kind of be 150. At 6, it's going to be 99, which is practically 100. At 7, it's 70. Well, that's nice. So a little above this 50 mark. At 8 is 49, so that's like basically 50. And let's check the values for 9 and 10. 9 and 10. 35 and 24. 35 and 24. So again, at 9 it's going to be like 35 over here. It's going to be here. Now I'm gonna connect the dots. I'm going to connect the dots. Before I graph anything else, I'm going to connect the dots. So this is how you're supposed to do graphing, right? And I'm going to show this arrow to show that it goes on continuously, right? That part is important, right? Sometimes, it's defined in such a way they deduct points for that. So you want to be accurate in your work. Now I'm going to make the table for B of t again. B of t. I'm going to t here and y here, right? I'm going to go all the way from 0 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, again. So B of t, I'm going to start at 400, so I'm going to write it down here, 400. Now let's check the values. For 1 and 2, 317, 252, 200. 317, 252, and 200, and now we're 3. At 4, it's 158, 5, 126, and 6, 100. 158. Oh man, I already forgot. 158, then 162, and 158, 126, and 100. 126 and 100. You can obviously do this a lot faster. I'm having to switch between screens. That's why it's taking so long to fill out the values. And then at 7, 79, 63, 50. 79, 63, 50, and I believe this was 39. Again, same thing. I'm going to graph it. Same thing. At 0, B of t starts at 400, so I'm fine. At 1, it goes to 317, which is kind of around here. All right. At 2, it goes to 252, which is like midway between 200 and 250. At 3, it goes to 300. It goes to about 200, right? About 200 here. Oops. 200 here. All right. And 5, it goes to 126. So a little below here. 26. And then at 6, it goes to 100. So a little above this because 100 is over 99. At 7, it's 79, which is a little above this, which was 70 here. At 8, it's 63, so it's going to be a little around here. At 9 is 50, so midway, and this is 39. All right, so now I'm going to connect the dots. Boom, 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 boom. And look, it intersects around here, right? I'm not the best drawer, so it intersects around here. So this is what this looks like. All right. Okay, so now that we have that, we can see it kind of intersects around this area, right? So around this area here, the graphs intersect. I'm just pointing that out for reference. All right, now we're done with the graph. So that's how you graph anything properly. Now it's saying to the nearest hour, when does the dose amount given to when does the amount of a given drug remaining in patient B begin to exceed the amount given the drug remaining in patient A? So again, their nearest hour. This is keyword nearest hour, and it's not saying algebra, right? So you don't need to look at the algebra. You can just kind of look at the table and make an estimate here. So nearest hour, we kind of wrote down our table here. We can see at a certain hour, one of the graphs value is higher. At hour 6, it's 100 for B of t, and at hour 6 for A of t, it's 99. So we know around 6 hours, there's more B of t left in the body. So we could say at hour 6, patient B has more of the drug remaining in their body. Again, this did not say algebra, so you don't need to do any algebra. You could have done looked at the table, but we wrote our table here, right? We wrote our table here, so we didn't need to go back and check the table. We can see at around 6, nearest hour, the drug began to exceed in patient B, hour 6. All right. Now it's asking, the doctor will allow the patient A to take another 800 milligram dose of the drug once 15% of the original drug is left in the body. Determine to the nearest tenth of an hour how long patient A will have to take another 800 milligram dose of the drug. All right, so for this one, again, they're not saying algebra, so you don't need to do any algebra here, but I'm going to show you how to do it algebraically, and we can also do it through the graph, right? Also do it through our table and the graph. All right, so let's take a look here. Let's do it algebraically first. So what is 15? Let's break this down. What is 15% of 800? So do some work here. 0.15 times 800, and that's going to be 120. So I'm going to set 120. That's my output equals. Again, we're checking with patient A, right? So patient A, the formula is 800 e to the minus 0.347t. All right. First thing we do here, well, what do you think we're going to do? We're going to divide both sides by 800 because we want that t by itself. That represents our time. All right. So that's going to give us 0.15 equals e to the minus 0.347t. All right, I want the t up front. How can I get rid of e? What operation lets us get rid of e. It's not log, it's ln. So I'm going to ln both sides. I'm going to ln 0.15. So I'm going to continue my work here. Equals, now ln e to the minus 0.347t. So when you ln e, they cancel out. So I'm left with ln 0.15 equals minus 3.47t. So I'm going to divide both sides by this amount, minus 0.347, to get the t by itself, minus 3.47. It's going to cancel out. And if you check in the calculator, all right, so let's just do it, right? Let's check in the calculator. Let's put this in the calculator. Second quit. ln 0.15 divided by negative 0.347. That's going to give us 5.4672. But again, the question asks to the nearest tenth of an hour. So that's going to round to 5.5. So this is going to be t equals 5.5 hours. All right, so that's how you do it algebraically. And we could have done the same thing for the last problem if we wanted to do it algebraically. All right, how can you do this with your graphing calculator to make a best estimate? Again, you go back to the graphing calculator, you go to your table, second table here. We're only concerned about a of t, so we're gonna look at this function, right? We can see between our 5 and 6 is between 144 and 99, which is almost 100. So between 144 and 99. And we know we want 120. That's our output. Since it's kind of in between, all right, so we can say t again equals 5.5, right? Because 120 is between 144 and 99. So again, we can get this answer through the table. All right, so I hope that answers some questions how to solve this problem. Let's do the next problem, which is from August 16. All right. Seth's parents gave him $5,000 to invest for his 16th birthday. That must have been a long time ago if you guys know Seth, right? He is considering two investment options. Option A will pay 4.5% interest compounded annually, and option B will pay him 4.6% compounded quarterly. Write a function of option A and option B that calculates the value for each account after so-called n years, right? All right, so let's take a look here. What do we have to do? This is an interest thing, right? We're doing some interest stuff, so we have to use the interest formula. That is given to you on the regions. You just got to look at it. Let's take a look. Right? So again, the interest formula is in the front of this document. This is taking so long. One day. So over here, this is the interest formula right here. This is given to you on the regions. All right, so let's write that down. Okay. So the interest formula is a to the p1 plus r over n to the n times t, right? I'm just writing that down for reference. It's given to you, but I want to be able to use it. All right, so let's find the functions here. So a, now it's just saying a, it's not saying a of t or anything, or a of x. So we're going to say a equals here, right? So 5,000, which is the initial amount. That's P right there, 5,000. Why did I switch color? I'm going to rewrite this in blue. A equals 5,000. No, 1, which stands for 100%, plus R. For R, option A is 4.5%, so 0.045. Compounded annually, so my n here is 1. I only compound once a year, to the power n times t. But what is our n here? It's 1, so it's just times t. So you're going to get something like 5,000, 1.045 to the power t. Now for B, it's going to be a little different. For B, we're going to do the same thing here. We're starting at 5,000. All right, 1 plus R, which is 0.046 over quarterly. Quarter, how many quarters are there in a dollar, right? There's 4 of them. So over 4, n times t, n is 4t. So we want to work this out, right? You could kind of leave it like this. That's fine too. They'll accept that as an answer. So we can just leave it like that. That's an acceptable answer. They didn't ask us to simplify or anything. So this is fine for A and B. Now let's take a look at the second part of the question. Seth plans to use money after he graduates from college in 6 years. Determine how much more money option B will earn than option A to the nearest cent. So we gotta just find what are these values at in year 6. Now it's not asking you to do algebra, right? So we could plug this straight on our calculator and see what we get. All right, so I'm going to go to my graphing calculator. All right, I'm going to go to y equals. I'm going to clear this and I'm going to clear this. I'm going to put both functions in. I'm going to do A is 5,000, parentheses 1 plus 0.045 to the power t or x. That's the first one. B of t in y2 is 5,000, parentheses 1 plus, I have a fraction here, alpha y equals n slash d. That gives me my fraction 0.046 over 4 because it's being compounded quarterly, close parentheses, to the power 4x. All right, so now I'm going to click second graph, which gives you my table. I'm really interested in what? I'm interested in year 6. Year 6. So I'm going to write down the values at year 6. Year 6, A will be 6511.30 on your calculator. All right, now if you don't see all the pennies and cents and so on and so forth, what you can do is just put in 6 here, right? You get this from, I'm gonna write it in some chicken scratch right here to find A. You're just gonna find, plug this in, 5,000, 1.045 to the 6, and that'll get you that, right? That will get you A here if you can't see all the decimals and stuff in your calculator. And B at year 6 will be 6578.87. All right, let's add the dollars because we're counting money here, right? Green for dollars. Now it's asking how much more will option B earn more than option A. So that's key. You have to fully answer the question, you have to be like, oh, how much more? What do we have to do here? We have to do some subtraction here. We have to subtract A from B after 6 years. So we're going to do 6578.87 minus 6511.30, and that's going to give us, let's put this in the calculator, quit 6578.87 minus 6511.30. Enter. That's going to give us 67.57. All right, so this is going to give us $67.57 more will be saved at year 6, right? All right, so we're done with that part. Now it's saying algebraically determine to the nearest tenth of the year how long it would take for option B to double. All right, so to do part 3, now keyword here is algebraically, so we have to do the algebra here. Again, another keyword, nearest tenth of the year, how long it would take for option B to double Seth's investment. All right, so what's Seth's initial investment? Seth's initial investment is $5,000, right? So to double it, we times by 2. That's going to give us $10,000. Right. So now that we know what the doubling amount is, which is 10,000, that's our output, we have to find how many years it will take. So we're going to set 10,000 equals to our equation here, which is 5,000. Remember, this is option B, account B. 1 plus 0.046 over 4 to the 4t. All right. So first thing I'm going to do, well, I'm going to do two things, right? First thing, I'm going to divide both sides by 5,000 to get this variable by itself, right? That's the first step, to get the t by itself. So I'm going to get 2 equals, now I'm also going to resolve this on my calculator, right? So I use my calculator here off screen, and it's going to give me 1.0115 4 to the t. Remember, to get the t by itself, now I can do two operations, log or ln. They give me the same answer. It doesn't matter, right? So let's just do log, right? Because we used ln earlier. Let's do log 2 equals log 1.0115 to, now what happens to the exponent? When you log or ln, it comes to the front, 4t. Remember, I want this t by itself. That's the name of the game. That's the name of the game. So I'm going to make sure, I'm going to get rid of everything on this side that's not t. So I'm going to divide both sides by 4 log 1.0115 to cancel this stuff out. What if I do on one side? I have to do on the other. So 4 log 1.0115 on the calculator. All right. So this cancels out. This cancels out. All right. Let's see what this is. So I get this value equals some value t. I get t equals, now it's time to open up your calculators. All right, so clear my calculator. All right, so I'm going to have log 2. All right, this was in a fraction, so I'm going to do alpha y equals n slash d log 2 divided by 4 times log of 1.0115. All right, I get 15.15248. So, but I don't want all that stuff. It says to the nearest tenth. It says to the nearest tenth. So that rounds to 15.2. So t is 15.2 years, right? So it'll take 15.2 years for, that'll be the amount of years it takes for account B to hit $10,000. All right, so make sure you write the word years here because it's asking for years. All right, let's move on to the next example. The speed of a tidal wave S in hundreds of miles per hour This is January 17, question 37. Again, the speed of a tidal wave S in hundreds of miles per hour. Now, this is key. Hundreds of miles per hour, right? This is key, as you see later in the problem. Can be modeled by the equation S equals square root of t minus 2t plus 6, where t represents the time from its origin in hours. Algebraically determine the time when S equals 0. When S equals 0. So, they want us to do algebra. They don't want us to do anything else here, right? But where I'm going to show you another thing you can do, and maybe you'll be able to get a point. But let's do the algebra first. So my output here, when S equals 0, I'm going to replace S with 0. Use a different color here, magenta. Actually, I've been using magenta a lot. Let's use dark green. Yeah. So 0 equals square root of t minus 2t plus 6. All right, this is a radical problem. Radicals is, you want to get the radicals by itself. So I'm going to get rid of everything on this side. So I'm going to plus 2t minus 6 on this side, plus 2t minus 6 on this side. I want this radical by itself. So I'm going to have 2t minus 6 equals the square root of t. Square root of t, not 6. So now the name of the game here is square rooting. Square rooting both sides to get rid of the square root. So this becomes 2t minus 6, 2t minus 6. I can't just distribute this 2 here, because why? There's a minus sign in between. I can't do that. There's a minus sign in between. That's why I have to FOIL, right? PEMDAS, parentheses first. I can't do the exponent yet. And that's gonna, but over here, I can distribute the 2 completely, because this is just one term. There's 2 terms in here, and I can't do that. So it's because just one term, and it's all multiplication or division here, I can distribute this. So square root of t squared is just going to be t. Now let's FOIL this. We're going to get 4t squared minus 6t minus 6t plus 36 equals t. Let's put everything to one side. We're going to get 4t squared minus 12t minus 35, right? Am I doing my math right? No, I do not know how to do my math. Okay. All right. I did that whole thing wrong, so I'm just I'm just multiplying. I see my mistake now. So 2t minus 6 is minus 12t. Minus 6 times 2 is, again, another minus 12t. Minus 6 is plus 36 equals t. All right, so I'm going to have 4t squared minus 24t plus 36 equals t. I'm going to move everything to one side because it's quadratic, right? So I'm going to continue the work up here I'm going to pick a different color. I don't like dark green. Let's pick purple. I'm going to rewrite the equation here. So 4t squared minus 25t plus 36 equals 0. How did I get 25t? I subtracted this t from both sides. Right, so this became 0 here. This canceled out. Minus 24t minus t is minus 25t. All right, now you can use the quadratic. You can factor it. All right, so I'm going to use the quadratic formula here. So let's do that. So I'm going to define my a equals 4, b equals negative 25, and c equals 36. And I'll put it in the quadratic formula and see what I get. So now I'm going to have minus, b is minus 25, plus minus square root of minus 25 squared minus 4 times a, which is 4, and c, which is 36, over 2 times a, which is 2 times 4. Now I'm going to have to put all of that in the calculator. So let's go. Let's put all of that in the calculator. Click the calculator. So get my fraction going. All right. So I'm going to have minus negative 25. Let's do the minus part first. Minus second square root, parentheses, negative 25 squared minus 4 times a, which is 4, and c, which is 36. And all of that over 2 times 4. All right, so I'm going to get 2.25. All right, we got 2.25. Give me a second. The first one I'm going to get is t equals 2.25. All right, and I'm going to get another value. I'm going to get the plus part. So I'm going to go back here. I'm going to enter. I'm going to go back. And I'm going to change this minus sign over here to a plus, right? Delete plus. I'm going to hit enter here. All right. So I'm going to hit enter here. And I'm going to get 4. So that's my other value. So t is going to be 4. Now, they can't both work, right? They cannot both work. So we have to choose one of them, right? What you have to do now is you have to check, right? You have to plug both of them back in to the original equation using t's to see if it works, all right? So I'm going to check this one first to see if this one works. All right, so I'm going to go to my calculator again. Right, so I'm going to check. So second square root 2.25 minus 2 times 2.25 plus 6. What does that give me? That gives me 3. S is supposed to be 0, but this is giving me 3. So I'm gonna reject this. This is an extraneous solution. Reject this, right? Reject this. Right, this is not gonna work. So this is my solution here, right? T equals 4. So at when it's 4 hours, the tidal wave is like 0 or something, right? That's what that means. Now I'm going to show you how to do it graphically. Like, let's say you forgot how to do this, and you don't remember the algebraic process, but you can still do this, and maybe they'll give you a point. So I'm going to go over that. I'm going to go to the calculator. I'm going to go to y equals, right? I'm going to clear this stuff up. I'm going to put in my equation. Put in my equation, which is second square root x minus 2 times x plus 6, all right? Now I'm going to maybe graph it here. Well, I can't. Right, I got to readjust my window. Right, maybe 800 is too much. Maybe like 10 or something. Graph it, right? Oh, okay. All right, so graph it. You can see, right, in the graph. You can see in the graph when it hits 0, when y equals 0. You can see in the graph right here, right? Can you guys see that? Like right here, it hits 0. You can also check through the table, right? At the table, 4 equals 0, right? And that's what we're looking for. We're looking for s equals 0. So even if you can't do it algebraically, plug this in the calculator, and you might be able to get t to the 4, and that might be a point. All right. Now it's asking how much faster was the tidal wave traveling after 1 hour than 3 hours to the nearest miles per hour. Justify your answer. All right, so let's take a look at our question here. We have to, again, nearest mile per hour. Justify your answer means you gotta show work, right? That's how you justify your answer here. So we're gonna find it when we at 1 hour, we're gonna find S at 1 hour, and we're gonna find S at 3 hours. All right. So S at 1 hour is going to be, what am I gonna square root of 1 minus 2 times 1 plus 6. All right. So this is kind of simple here, right? So 1 minus 2 is negative 1 plus 6, and that's going to give me 5, right? So at 1 hour, right? At 1 hour, that's what it's going to be. And now let's check at 3 hours, right? So 3 hours, I'm going to get, let me do this in blue. 3 hours, I'm going to get square root of 3 minus 2 times 3 plus 6. All right, let's put that in the calculator. All right, so we could also look at our table because we put it in 1.73, but I'm just gonna do the calculation again on the calculator. So I'm gonna have second square root of 3 minus 2 times 3 plus 6. That's gonna be 1.73205. So that's gonna be 1.73205, like so on and so forth. So now it's like, oh, how much more nearest mile per hour? So, okay, so you're thinking, oh, I'll just do 5 minus 1.7305, and that's going to give me something like 3.2. 3.26 or something, right? It's going to give me something like that. That's completely wrong, right? That's completely wrong. Well, not completely wrong, right? But you'll get a point off for this because S is over here. I'm highlighting here in purple, right? Over here. S is in hundreds of miles per hour. So you have to multiply this amount by 100. So 3.26 times 100, and you're going to get 326. 326 miles, right? So you're going to get something like that. Now, it didn't say to round or anything, so this is good enough, but if you really want to be safe, right, put in the decimals here, right? So let's do 5 minus this answer here. So 3.2679, 3.2679. And now I have to round nearest mile per hour. This rounds to 327. So 327 miles per hour. All right, that's what would happen here. All right, and that's that question. Now let's go to June 17th. All right, question 37. Give me a second to get water. A radioactive substance has a mass of 140 G at 3 p.m. and 100 G at 8 p.m. Write an equation. Key word here. It says equation. Equation. It does not say function. In the form of A equals A0, that model A0 times 1/2 to the power T over H, which is the half-life equation, that models the situation where H is the constant representing the numbers of hours in half-life, and A of 0 is the initial mass, and A is the mass T hours after 3 p.m. All right, so first thing we have to do, so A is our output, is the mass after a certain amount of hours, right? So A here is 100. 100. Remember, they want an equation. They don't want a function. 100. Our initial amount here is 140 at 3 p.m. 140, 1/2. And how many hours are between 3 p.m. and 8 p.m.? There's 5 hours. So your T here is 5. T here is 5 over H, right? This is kind of a reading comprehension problem. They're trying to trip you all up. Now, so they're saying using this equation, solve for h to the nearest 10,000. All right. Although they don't say algebraically, let's do the algebra here. I'm going to do the same thing. 100 equals 140 to the 1/2, right? 5 2 over h. All right. And we're trying to solve for h here. I'm going to divide both sides by 140. That's the first thing I'm going to do. Divide both sides by 140. All right. That's going to give me 5 over 7 equals 1/2 to the 5 over h. All right. So let's continue our work here. I want the h by itself, right? So I'm going to log this, right? I'm going to log 5 over 7 equals, remember when you log something, the exponent comes to the front. So I'm going to have 5 over h log of 1/2. All right, so this is kind of really, really tricky. All right, I want the h by itself. It's in the denominator. So I'm going to multiply both sides by h. I want to get rid of the h in the denominator and put it in the numerator. The only way to do that is multiplying both sides by h. So these h's cancel out, and I have an h here. So if h log 5, 7 equals, now this h is gone, 5 log 1/2. All right. Now, to get the h by itself, I'm going to divide both sides by log 5 over 7. Not equals. So this cancels out, over log of 5 over 7. Wow. All right. So let's put that in the calculator, right? Now I have everything I need to get this h by itself. Let's go back to our calculator. Let's clear this up. So let's get a fraction here, log. All right, so log, parentheses, we have another fraction, so alpha y equals n/d. 5 divided by 7, parentheses, divided by, oops, man, I'm messing up, right? This is a big one, right? This is actually alpha y equals n/d. 5 log, parentheses, 1 divided by 2, 1/2, over, and the whole thing is divided by log of 5 divided by 7. All right, that should be it. That'll get us something. That gives us 10.03002 hours. All right. The question said solve for h for the nearest 10,000th. So the 10,000th is here, over here. That 2 right there, the 213 is the 2 right there. So I'm going to say h equals 10.3002, right? They said nearest 10,000, so I'm going to run to the nearest 10,000. And that's your h. And that's how you get full credit for that question. Now it says determine when the mass of the radioactive substance will be 40 g. Round your answer to the nearest tenth of an hour. Plenty of ways to do this. They did not mention the algebra, so let's try doing our best to solve this problem, right? We're going to do it algebraically because we just got so much practice doing this, right? So 40g, right? So that's my output. So I'm going to say 40 equal to the equation. 40 equals 140, 1/2. Now I'm looking for time, right? So I don't know the time here. T over, we just found h, 10.3002. All right. Same thing, we're going to divide both sides by 140. All right. And you're going to get now 2 over 7 equals 1/2 t over 10.3002. Same thing, same process here. All right, same process here. I'm gonna continue my work here. Now I have to log both sides because I want the t by itself. I'm gonna log 2 over 7 equals t. Remember, the exponent comes to the front when you log or ln something, over 10.3002 log of 1/2. All right, so again, I want the t by itself. That's what I want, right? It's being divided by 10.003, so I don't want that. All right, that thing is annoying me. So if it's being divided by it, I have to multiply both sides by 10.003. All right, so I'm gonna divide both sides by 10.003. So I have 10.3002 log of 2 over 7. All right, and now I realize it's also being multiplied by log of 1/2. So I'm gonna divide both sides by log of 1/2 as well. Because I want the t by itself, so I don't have t, and this whole side is going to be divided by log of 1/2. We're just doing the same thing that we did in the previous problem, previous part of the problem, sorry, and we're just solving for t here instead of h. So let's put that all in the calculator. Oh boy. This is terrible. So we have a fraction here. Oops. I'm getting an add on my calculator. I don't know when this is going to go away. No, I do not want to go to Reddit. All right. So I have log. Sorry, the first thing here is, let me clear this. Clear all. Second, clear all. All right. So I'm going to have alpha y equals n/d 10.3002 times log of 2 divided by 7 over, and the whole thing is over log of 1 divided by 2, 1/2. And what is that going to give me? It's going to give me 18.6, right? It's the nearest tenth of an hour, so I'm rounding to the nearest tenth. So it's going to be 18.6, right? So I'm going to get 18.6 hours, right? And that's my final answer. Oh, man. A lot of exponential problems so far. Oh, great. Another exponential problem. All right. So let's take a look at this question. August 17th, question 37. The value of a certain small passenger car based on its use in years is modeled by V of t 28,482.698 times 0.684t, where Vt is the value in dollars and t is the time in years. Zach had to take out a loan to purchase the small passenger car. The function zt equals 22151.327 times 0.778t, where zt is measured in dollars and t is measured in time, models the unpaid amount in Zach's loan over time. So Vt is the value and zt is the loan, right? So state when, first part of the problem is asking, state where Vt equals zt to the nearest hundredth, all right? So there's a couple of ways how to do this example, right? Again, it doesn't say the algebra, so we've been doing a lot of algebra so far. So let's put the equations in the calculator. So we're going to put V of t and Z of t in the calculator. Calculator y equals. All right. So first function, V of t, that's going to be 28482.698 parentheses 0.684 to the power t, and the other one, which is his loan, is 2251.327 times 0.778 to the power x. All right, now I'm going to click graph. Well, I don't see anything. Why? Well, now I'm going to investigate my table. All right. Remember, we're calculating in time, so the lowest our x could be is 0. But let's look at our y value. What's the highest y value here? I see 28,000, right? 28,000, all right? And it keeps, and the next highest value in y2 is 22,000, and it keeps descending, right? So maybe I'm going to adjust my graph a little bit, all right? Adjust my graph, my window, so window x minimum 0, great. X max 8 looks good so far. Y minimum 0, Y max 10. No, I saw the Y go up to 28,000 something. So I'm gonna punch a little above. So I'm gonna go to 30,000. Now I'm gonna click the graph, see what it looks like. Oh, that's great. I'm seeing something finally. All right, that's a good thing. All right, now it's asking when V of t equals Z of t. The way to do this on the calculator is you go to second trace, which gets you to calculate, and you're going to look for the intersection of the graph. All right, the intersection of the graph. So first it's going to ask left bound. All right, so you want to be left of the intersection. I see the intersection here. All right, I see the intersection here. So I'm going to click enter. Now right bound, I want to be right. I want to be right of this intersection line right here. So I'm going to click enter. It's going to ask you to guess. All right, click enter again. All right, so the intersection is at x equals 1.95, y equals 13,000, blah, blah, blah. I don't care about the y, right? Because asking at what time, right? So it's at 1.95. They said nearest 100, so I'm writing to the nearest 100. So I can write here v of t equals z of t when t is approximately 1.95. All right, so we could say, right, now we're looking at, now what does v of t and z of t stand for? V of t and z of t stand for, v of t stands for the value of the car in dollars, and z of t stands for the loan, right, to purchase the dollar. So we have to interpret what this 1.95 means, right? We could say at 1.95 years, I don't know how to spell years, the value of the car, which is v of t, is equal to the unpaid amount of Zach's loan, right? Like, so something like that. So you want to say what the two functions stand for and how they're equal, right? And what does that mean? So that's what we can say. Or you could say at 1.9 years, the value of the car is equal to the amount remaining in Zach's loan, right? That's also a perfectly fine response. Let's take a look at the second part. Graph v of t and z of t over the interval 0, 5, right? 0, 5. Now it's only asking us to go from 0 to 5. All right, so that's great, right? So we're gonna have to graph all the way up to 8. So I'm gonna do 0, and maybe every 3 spaces I'll go up 1. 1, 1, 2, 3, 4, 5. And I know, right, the highest amount I saw was 28,000, so on and so forth. So I'm going to indent my y's properly too. So maybe every 2, I go up, let's say, So let's say I go up 2,000 per time, right? So 2,000, 4,000, 6,000, 8,000. So I have 10,000 here. 10,000 here. And then 12,000, 13, 14,000, 16,000, 18,000, 20,000. And then 22,000, 24,000, 26,000, 30,000, right? So 30,000. So that'll be just a little above what I need to graph. All right. So again, best thing to do here is to write down what the values are, or to kind of give an estimate of the values. So it's gonna be much easier for you. I have to switch back and forth. So right now it's time to look at the table. And you should go to the table and plot the points, right? So you have v of t, and that's going to be, so you have t comma y, t comma y. All right. This is a lot. T comma y. T is time, right? And y, because it's not labeled, is dollars. T comma y is at 0, 1, 2, 3, 4, 5. They don't want more than that. And same thing with z of t. Z of t. So t comma y. So I have 0, 1, 2, 3, 4, 5. And I'm going to find the amounts here. All right, so I put this in my calculator here. So I'm going to just write down the amounts. So this is like 28,482.70, 19.482.17. Now you don't have to do this. You can just graph, right? You don't have to make these tables here. You can just graph, but make sure you only graph one function at a time. All right, you get confused. So 13.325.80, 11, 4.85, 6234.56. And 5 years is the value of the car is 4,264.44. All right, so let's graph this. Let's graph the blue part here, right? So 28,070 at 0 years. So that's going to be a little below, make it smaller, a little below 30,000. At 1 year, the value is 19,000. So that's what happens when you buy a new car. Right? It'll be just below the 20,000 mark. All right. At year 3, it's going to be 13,325. So year 2, it'll be a little above this 10,000 mark here, 12,000 mark here. And which is going to be right here. And year 3, it's going to be about $9,000. So it'll be halfway between 10,000 and 8,000. So it'll be here. Year 4 is 6,200. So a little above this line here, which represents 6,000. And then year 5 is worth about $4,200, which is just above this line right here. I'm not going to graph anymore. I'm going to first connect the dots. Right? I'm not going to make an arrow here. If you make an arrow here, that's wrong. Do not do that. It only says to graph from 0 to 5. So I'm graphing just from 0 to 5. Now I'm going to graph z of t. I'm going to write down my stuff here. 22,151.33, 17,233.73, 13,407.84, 10,431.30, 8115.55 6313.90. All right, so I'm going to grab Z of t here. So 22,151 at 0 years. It's going to be a little above this 20,000. It's going to be around here. This is where 22,000 is. At year 1, it's going to be, the value will have decreased to about 17,000. So it'll be right below this 18,000 mark. At year 2, the value will be 13,000. So it'll be a little above here. All right. And year 3, the value will be 10,000, 431, so a little bit above the 10,000 line. And year 4, it'll be 8115.55, so it'll be a little above this 8,000 line, so it'll be right here. And it'll be 6,390, so it'll be a little above the 6,000 line. Now I'm going to connect the dots. All right. And look at that. Doesn't that look like it's intersecting over there? So that's what they want to see. That's what they want to see on the regions for full credit, right? The graph. You don't have to make the table. I'm just making the table for clarity's sake, so you can see what I'm graphing with the dots. Now, Zach takes out an insurance policy that requires him to pay a $3,000 deductible in case of a collision. All right. Zach will cancel the collision policy when the value of his car equals his deductible. To the nearest tenth of the year, how long will it take Zach to the nearest year, how long will it take Zach to cancel this policy? So when you see something like that, right, does it have the word algebra anywhere? No, we got lucky. It does not have the word algebra anywhere. But if you want to do the algebra, I'll leave the exercise to you. This is how you should set up the equation here. All right, so it's going to be 3,000 will equal the value of his car. And I'm going to put in v of t, the function for v of t, which is, because that represents value of the car, 28,042.698.684 to the power t. All right, so we've done a bunch of these so far. So if you want to do the algebra, this is how you should set up the problem. Follow the steps, all right? But it doesn't say algebra here, so we can save some time here. We can go to our table. Second table. So I want to know when it's going to be around 3,000. Look at that. The value of the car, as in Y1, around year 6 is 2,900. So to the nearest year, so 3,000 is not that far from 2,900. It's set to the nearest year, so it's at 6 years. So I could say at 6 years, it would be okay for Zach to cancel the policy as the car is worth less than the deductible, something like that, right? Deductible, right? That's what that means, right? So the deductible. All right. We don't have to do any algebra here because they did not specify algebra. But if you want to be safe and you think, oh, I know how to do the algebra, I'm very confident, so do the algebra. Make sure it matches the answers in the calculator as well. And do the algebra just to be, if you really want to be safe. But if it doesn't say algebra, you don't have to say algebra. All right? All right. And how do we justify? We could say we found this value, right? Found this value on table of v of t, right? That's how we justify that. All right. Okay. All right. So let's take a look at question 37 for January 18th. It says the resting blood pressure of an adult patient can be modeled by the function P below, where P of T is the measure in millimeters of mercury after time in T seconds. So P of T is 24 cosine 3 pi T plus 120. First thing, on the set of axes below, graph y equals pt over the domain t is between 0 and 2. All right, let's take a look at our graph. So we can see our graph is already kind of defined, right? From 0 and halfway between is 1, and they want to go get us all the way to 2. So that's 2 right here. All right. And we see a breakage at 90, right? A breakage at 90. So we'll figure out what to do with that after we break down the problem. So to graph this function, any trig function, first thing you need to do is you need to find the period. So let's find the period first. So period equals 2 pi over b, which is 2 pi over 3 pi, okay, and that's 2 over 3. All right, so 2 over 3 is our period. All right, and now we want to find our interval, right? And our interval we can find is interval equals p times 1 over 4, which is 2 over 3 times 1/4, which will be equal to 2 over 12. If we reduce that, that's 1 over 6. All right, so we want to say this is the period here. So this is the period. And what is happening here? Determine the period, explain what the value means in context of the given, in the given context. So this means every 2 seconds, the blood pressure pressure. Let me erase this part here. Just write that above. Write that here. Interval equals 1 over 6. All right. Every 2 seconds, the blood pressure, we can say oscillates or cycles, right? Cycles 3 times. All right. So that's what that means. Because the period is 2 over 3. All right. So let's break this down. We have the period now. We have the interval. So let's start graphing it. All right. So remember our interval, we go by over 1 over 6 each time. So let's see. We hope these indents work out here. So I'm going to do it in a different color. So 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, and 6 over 6 is 1. So that worked out. Oh, that's great, And we can see it increases by a certain amount each time. We can see this halfway through. So we could write that this is just 1.5, and this is good enough. But if you really want to be technical, you can, fill this out fully, right? This would be 7 over 6, 8 over 6, 9 over 6, 10 over 6, and this is 11 over 6, and 12 over 6 is 2, right? If you reduce it. All right, so now that we have our interval, let's find our midline, right? Where is the middle of the graph, right? The middle of the graph is, our midline is 120. So 120, right? That's the middle, right? So we start at 90. Maybe we'll go up by maybe 10 each time, right? So let's go 90, 100, 110, 120, 130, 140, 150, 160. All right, and see, let's hope these values work out here. All right, so this is a cosine graph, right? This is a cosine graph. So we have to find the maximum and minimum of the graph. There's a positive cosine graph. So to find the maximum, I get A, or I should say K plus A, which is our A is 24. Our K is 120, so 120 plus 24 equals 144. And our minimum is K minus A, which is 120 minus 24, which is going to be 96. All right, so the blood pressure is going to oscillate between 144 and 96 according to this function. All right, and there's a positive cosine, and positive cosine, looks something like this, right? It starts at the top. All right, so let's get started. So because we start at the top here, our first interval at zero, I'm going to be at 144. That's about halfway between here and here. All right. And let me just trace the midline over here, so it'll make my life easier while I'm graphing it. All right. At the next interval, the cosine function falls to the midline. So at 1 over 6, I'm going to be at 120. At 2 over 6, I'm going to go to like 96 over here, which is my minimum. At 3 over 6, I'm going to go over here, back to 120. And at 4 over 6, I'm going to be back up here. And 4 over 6 is, if you reduce it, is 2 over 3. So that's our period, right? So we get one hole in our period. And now we have to continue. It doesn't say, oh, I'm done. I graph one period. I have to graph all the way from 0 to 2. So let's just continue the pattern. So down here, next interval to the minimum, back up top, up here, down to the midline, down to the minimum, back to the midline, and back to the maximum, all right? And now I want to make a nice curvy, right? This is my function, and I'm not making the arrow C because it's from 0 to 2, so I stop right here. It's my function P of T, all right? And that's the whole thing graphed from 0 to 2. All right, so that's the full graph. We answered this problem here, this bottom problem earlier, which helped us solve the graph. And now let's take a look at the next question. The normal resting blood pressure for an adult is 120 over 80. This means the blood pressure oscillates between a maximum of 120 and a minimum of 80. Adults with high blood pressure, 144 over 90, and adults with low blood pressure, 90 over 60, may be at risk for health disorders. Classify the pressure's blood patient as low, normal, or high, and explain your reasoning. So, we're looking at the maximum and the minimum blood pressure. So 120 over 80 is called the normal. So what is this patient's, right? What is our maximum blood pressure here? We found that earlier. It's 144 over 96. So 144 over 96. And if we look, right, that qualifies as high blood pressure over here. High blood pressure is 144 over 90. So we can say the given patient's blood pressure is high because or because, I don't know, maybe the values for his pressure are between 144, between 96 and 144, which is higher than 90 and 140, and which is high blood pressure. All right, I probably overworded this problem, but I want to be as precise as possible. So that is the full answer. You get all that, that's 6 points on your Regents, right? A similar question like that. All right, so let's move on to the next problem. All right, June 18th. Website popularity ratings are often determined using models that incorporate number of visits per week a website receives. One model for ranking websites, P of X, is log x minus 4, where x is the number of visits per week in thousands, and P of X is the website's popularity. So let's underline some keywords here, right? So we have visits in weeks per thousands, right? So in thousands, right? That's what it's saying. So now it's saying, now let's answer the question. So I think that thousands part is going to be important. According to this model, if a website is visited 16,000 times in 1 week, what is the popularity rating rounded to the nearest tenth? All right, so because it's 16,000, we have to kind of break down the 16,000 into, let's see, let's put this in the calculator, right? Let's put this in the calculator. Oh my God. Log of x minus 4. Let's put this in the calculator. Let's get an idea of what's going on. All right. Clear. Log of x minus 4. All right, let's have that. Let's graph it. Let's see what it looks like. All right, I gotta adjust my window. All right, we'll worry about that later. Let's look at our table. Oops. Look at our table here. All right. Oh, my thing crashed. Error, of course. So this is log of x minus 4. All right. Let's look at our table here. Error. Lots of errors. I start technically at 4, right? But it doesn't show on the calculator. And at 5, it reaches 0. All right. So let's go back to our problem. All right. So we're going to say what is popularity in the nearest tenth. We can say now that, let's find this, P of 16, right? P of 16, because it's thousands per week, equals log of 16 minus 4. Yeah? We can write that down, right? And let's calculate that. What is that going to be? Second quit. Let's do log of 16 minus 4. Enter. That's 1.07, but it said round to the nearest tenth, so it's 1.1. So it's the 1.1 popularity rating. All right, so 1.1 popularity rating, and maybe I want to circle that answer or box it up so they see what's happening. Again, why did I put 16? Because it's 16,000 visits, so P of 16. And wherever I see x, I input it into here, right? And that gave me 1.1. Now it says graph P of x on the axes below, right? Graph P of x on the axes below. So remember, we've done a couple of graphing problems here. and we want to be precise as possible. So let's graph P of X, right? I remember from earlier, P of X at 5, it equals 0. So let me get a different color here. So it's 0 here. So it's 0 here. And then at 6, it's a little above 1. All right. And let's take a look at our table. Second table. Our table, so 0.3, 0.4, 0.6, 0.7, 0.6, 0.7, like 0.77, 0.8, 0.9, and then eventually at 14 we reach 1, right? So let's graph all that, right? Let's graph all that, right? You know, I got a little ahead of myself. So let's break this down. There's 1 here, so each indent is worth 0.25 because there's 4 of them. 0.5, 0.75, and so on and so forth, right? So let's keep going. Let's graph a little bit. All right, at 0.47, 0.6, 0.7. All right. So at 7, it's gonna be like 0.47. It's gonna be like 0.6, which is a little above 0.5. And there's gonna be like 0.77, which is gonna be like right here. Sorry, 0.7. It's gonna be a little before this. And 0.77, which is gonna be a little above here. And you know, eventually at 14, I'm gonna hit 1, right? So it'll be just be slowly decreasing. Right, so I remember at 14 it equals 1, right? So 14 equals 1. Now I have to keep going, right? Let's find a couple other points that we need to do. Do I hit any more whole numbers? Well, I can see the graph goes a maximum of 120. So maybe I'll choose 2 points between, maybe I'll choose like 17, which is 1.1. and 20, which is 1.2. So I'm going to go back here. So at 17 is about 1.1. And at 20 is about 1.2. So I'm going to connect these dots, right? And I'm going to label this P of X. All right? P of X. All right. An alternative rating model is represented by R of X equals 1/2 x minus 6, where x is the number of visits per 1,000 weeks. Graph R of x in the same axes. For what number of weekly visits will the two models provide the same rating? All right, so there's a couple of things we need to do here. Let's first put this function into our calculator. All right, y R of x is let's put on a fraction, 1/2 x minus 6. All right, and remember we have to adjust our window because I was doing a problem earlier. So let's go back to our window. Our x minimum is 0, our x maximum is 20, our y minimum is 0, and our y maximum is a little above 4, so 4.25. All right, and now let's graph this. All right, so that's what it looks like. All right, so clearly we can see what's going on here. So at 12, R of x is at 0, and at 14, it's at 1, and they intersect there. And it seems to be going up by 1 each time. So let's graph that. Let's graph R of x. So at 12, it's at 0. At 14, they intersect at 1. At 16, it goes to 2, which is right here. At 18, it goes to 3. And at 20, it goes to 4, right? So that's R of x. I'll label this. There's two functions, so I have to label, or it's like which function is which. All right, so I can clearly see that they intersect at 14. So, Well, for what number, maybe you're like, oh, I'm going to write 14. Wrong. No, remember, it's thousands of views per week. So it's 14 times 1,000. And that's going to be 14,000 views, right? And that's my answers, or view/site visits, right? So that's my answer, and that's the whole problem right there. Some of it's like kind of a reading comprehension with the thousands, because if you mess up, right, at the beginning of the problem was 16,000 and you put 16,000 here, 16,000 here, you got a totally wrong answer, and then it might make you mess up on this part too. So it's kind of a reading comprehension problem, which a lot of these problems are. All right, let's move on to the next problem. It says, August 18th, a major car company analyzes revenue, R of X, and cost C of X in millions of dollars over a 15-year period. The company represents its revenue and cost as a function of time in years X using the given function R of X, and there's a whole polynomial for that, and C of X, and there's some stuff going on there too. The company's profits can be represented as a difference between its revenue and cost. Write the profit function P of X as a polynomial in standard form. And then graph y equals P of X on the set of axes below between 2 less than or equal to x less than or equal to 16. All right, so we're going to need a little more space for this one. But this one, P of X is the difference between revenue and cost. So P of X is going to be P of X equals R of X minus C of X. All right, and obviously you'll have more space to do this, right? So I'm just gonna work this over here. So that's gonna be 550 x cubed minus 12,000 x squared plus 83,000 x plus 7,000 minus, now you want to minus this whole thing, 88,000 x cubed minus 21,000 x squared plus 150,000 x minus 160,000. All right, so remember, you're minusing this whole C of X. So I think what I just want to show you guys what this means. When you minus this whole thing, that means all the signs on the inside of it will flip, right? So I'm just going to do that now. So I'm going to do a plus here and distribute the minus sign, right? So because the minus, so it's going to become minus here, minus here, and plus here. And once you get all that, you can find P of X. You can do the math in it, right? Use your calculator. So 550 minus a 880x cubed, right? So I'm just going to write P of X here. P of X equals, and I assume you all know how to do basic subtraction. So this is going to be 330x cubed plus 9,000 x squared minus 67,000 x plus 167,000. All right, so that's P of X right there. All right. Now it's saying graph y equal P of X on the set of axes on the domain below, right? Okay, so let's do that. So now we have to put P of X in the calculator because that will help us graph. Let's go back to the calculator. Let's go to y equals, clear it up here. All right, so now I have to do this. Be very careful. Don't put a minus sign here. This is a negative sign. So negative 330 x cubed, all right, plus 9,000 x squared, oops, x, delete, delete. All right, x squared minus 67,000x plus 167,000. All right, and let's click graph. Well, I don't see anything. Well, what's the problem, right? We gotta look at our table, right? Look at our table here, and let's look at our values here. Graph table. Our values here, they're kind of like really high, you know. All right, and it says the graph, our x values are going to be between 2 and 16. So let's see the values between 2 and 16. So at the value of 2 is 67,000. All right, and I can see it goes all the way to 91,000 here, 80, and now it's going back down again, 87,000, 73, 47. So we have to adjust our window. So let's adjust our window, right? All right, so we're going to start at 0. We're going to go all the way to, let's say, 18. And the y minimum, we're going to, again, start at 0. And let's see, the maximum it went up to, I think the maximum went up to is like, let's do 100,000, all right? Because it went up to 90,000, all right? That's 100,000. Yep, all right. Now let's click graph. Graph. Oh, all right, all right. That's still not enough. I got to go a little higher. What did I do here, right? So let's go back to our window here. And that's not enough, so why is that not enough? Let's do 100, 120,000. Let's click graph. All right. I guess that's just how it looks in this calculator. On your TI-84, it should look a little better than this app right here. So I'm just going to change the window back to 100,000. All right, so graph. All right. Again, we're going to use our table to graph the function. So, you got to look at your table. You got to look at the values between 2 and 6. So let's take a look at these values between 2 and 6. And let's graph them, right? So you'll have the calculator in your hand, so you won't need to do as much work as I do here, going back and forth. So just make sure you are doing it properly, right? All right. Only between 2 and 16. All right. All right. So now let's go back to our thing right here. So remember, we're starting at 0. We're going all the way up to 100,000. So 0. So we have to pace ourselves here. We're going to 100,000. We can't do 1, 2, 3. No, we're going to go up like 10,000 at a time. So 10,000, 20,000, 30,000, 40,000. All right. 50,000, 60,000, 70,000, 80,000, 90,000, 100,000. Oh, wow, that worked out. All right. I'm going to go from, let's say, all right, we're going to start at 1 because you can't just randomly skip, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and I'll just add 17. But we're not supposed to graph more than 16, right? So graph it properly, and at 2, I'm at 66,000. So at 2, I'll change up colors. Lighter colored. At 2, I'm supposed to start at 2, right? So we have to be careful. At 2, I'm at 66,000. This is just below this here. between like 60 and 70,000. At 3, I go all the way down to 38,000, which is just below this 40,000 number. At 4, I'm at 21,000, which is just above 20,000. At 5, I'm at 15,000, which is halfway between 10,000 and 20,000. At 6, I'm at 17,000, which is a little above 15,000. All right, so the profit's starting to go back up. At 7, I'm at 25,000, which is halfway between 20 and 30. At 8, it's at 38,000. All right, so that number sounded familiar. And at 9, I'm at 52,000, which is just above the 50,000. And let's see, at 10, I'm at 67,000. No, I'm not moving around here. At 11, I'm at 79,770. So basically, at 11, I'm at, so it's basically about to be like 80,000, right? All right, so it's basically about to be like 80,000. At 12, I'm at 88,000, which is basically almost at 90,000. At 13, I'm at 91,000, just a little above the 90,000. At 14, I'm like back at like 87-ish, 87,000-ish. At 15, sorry. At 15, I'm at 73,000, so a little above the 70,000 number. And at 16, I am at 47,000. All right, so I'm going to connect the dots. Please draw better than me. I am not a good artist. You're getting graded on this and not me, right? No arrows because it gives us the domain here, right? And, I could label this P of X, right? Because that's my function right here. All right, so we graphed it. Great. So you needed to find P of X, put in the calculator, adjust the window, look at the values, and graph it. All right. Now, over the given domain, state when the company was the least profitable and most profitable to the nearest year, right? So the nearest year. So our x-axis is it's time, right? So our nearest year. So when was it the least profitable, right? Let's take a look at the bottom of the graph. This is the least profitable, right? We could say at year 5, it was the least profitable because it is the minimum. And let's write the value at 15,000. So look at your calculator, which is like 5750, I think. The minimum value over the given domain. And we could say at year 13, right? It's the highest, right? Year 13, it was most profitable because, all right, don't be like me, right? I'm not an English teacher, Don't misspell profitable. Like I have profitable. All right, there's supposed to be a T here, all right, not a B. Because 91 9190 was the highest value in the interval. And that should be a full explanation. All right, so that's that whole question. Again, the trick question here, the tricky part here is knowing to distribute the subtraction sign when you calculate p of x over here. And then adjusting the window can also be difficult. And the explanation is a little wordy, but we want to be as precise as possible when we do these problems. All right, let's move on to January 19th, right? Tony is evaluating his retirement savings. All right. He currently has $318,000 in his account, which earns an interest rate of 7% compounded annually. He wants to determine how much he will have in the account in the future, even if he makes no additional contributions to the account. Write a function a of t that represents the amount of money that will be in his account in t years. All right, so this is a compounding interest problem. It's a compounding interest problem. So they give you the formula. It's the first formula on the sheet, the first exponential formula, which looks something like this. It's a equals p 1 plus r over n and t, right? Where r is the rate, interest rate, and is how much it gets compounded per year, right? And t is time. Oh, and obviously p is the initial amount. All right, so that's the whole thing broken down. They give you this, so make sure you look for it on the sheet. All right, now we're just gonna input all the values here, right? So we have a of t. Remember they said a of t, so we're gonna write a of t equals p, which is the initial amount, which is 318,000. All right, parentheses 1 plus 0.07 over 1, all right, to the power 1 times t, right? And we can simplify that into 318,000 1.07, right, to t, and that's my actual real answer, right? So that equals a of t. All right, and either one is fine. You'll get full credit for either one. This one, it's kind of easy, right? It's just 0.07 divided by 1 is 0.07, so, and 1 times t is t. So that's a of t. All right. Oh my God, more graphing. Graph a of t between 0 and 20 on the set of axes below. All right, so let's graph this. All right, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so that fit perfectly. All right. And Tony's goal is to save 100,000, blah, blah. All right, let's graph this. All right, let's put this in our calculator. And let's get to graphing. A lot of graphic problems here. Let's clear this up. All right, so we have 318,000. 1.07 to the power, we don't have a t here, so it's to the power x, right? Let's graph. Well, we're not seeing anything. We got to adjust our window. So remember, we're going from 0 to clear 20. All right, and now we got to look at our table to see our values, right? So our table, we start at 0, 318,000, and let's see how high it goes, right? At 20, right? So it goes to some like 1.2 million, right? So it goes to something like that. All right, so let's go back. Let's adjust our window. Let's do 1.2 million, so a little over 1 point, so 3 zeros. Okay, let's click the graph. All right, so that's what it looks like. All right, so let's get to graphing here, right? So it's supposed to look like this, but we're going to use our table to graph. So this will be easier for you because you don't have to go back and forth. But I got to look at the table in here because I am doing it over here. So take these values here. Take these values here. Take these values here. All right, and now let's get back into it. All right, so now we gotta adjust. We can't, right? Like going up this way, it's gonna be tough because we can't go by 1 or 2. Remember, we go up to like a little over a 1.2 million. So let's do 100,000 at a time. So we could look at write 100 over here, 200, and I'll show you what I mean. 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100, 1,200, 1,300, 1,400, 1,500. All right, so we don't need to go above that, right? And this is amount, right? Amount in thousands, right? So amount in thousands. So but you could just do 100,000, 200,000, 300,000, and you don't have to write this part right here. You don't have to write this part. So if you just wrote 100,000, 200, 300, and you went all the way up to like 1.5 million, that would have been fine. And since we labeled this axis, let's label this as well. T stands for the amount in years. All right, and now let's get to graphing. Yay! All right, so we start at 318,000, which is like right here. And you know what? I'm gonna go up like 3 each time. So at 3, I'm at year 3, I'm at 380,000, which is just below this. At year 6, I'm at 477,000, which is a little above 450,000, which is between 400 and 500. At 9, I'm at like 580,000, which is just below the 600,000 mark. Oops. At 12, I'm at like 716,000. So over here. At 15, I'm at 877,000. So close to 900,000 here. All right, and at 18, I'm at 1,070,000. So it's gonna be a little above 1,000, like 1,000. Thousands is 1,000,000, and at 20, I go all the way up, a little above here. All right, so you connect the dots here. All right, so connect better than me. All right, so all right, so we're not doing the arrows because it's over a given domain. All right, so now it says Tony's goal is to save 100,000. Determine algebraically how many years it will take for him to achieve the goal. Again, another exponential problem. let's break this down. Let's use green here, right? So this is the output, right? And we want to find out how many years to the nearest years, how many years it would take to find that, right? So I'm going to set 100,000. I'm sorry, a million. 2, 3, one more equals 318,000. 1.07, and we're trying to find t here. So we're going to divide both sides by 318,000 because we want to get the exponent and eventually the t by itself. 318,000. All right. All right. So we're going to get something like 500 over 159. 500 over 159. You could also do a decimal here. 1.07t, right? And we want the t in the bottom, so we're gonna ln both sides, right? So I'm gonna continue the work here. We're gonna ln 500 over 159, and we're equals ln 1.07, and now the t's up front, right? T comes to the front when I ln, the exponent comes to the front. Now I'm going to divide both sides by ln 1.07. ln 1.07. All right. Divide both sides by ln 1.07, and I'm going to get, let's put that in the calculator. Second quit. Let's do a fraction. Alpha y equals n slash d. So we have ln of 500 divided by 159 over ln of 1.07. All right, so it says 16.93 equals t. So 16.93 equals t, but they want the nearest year. So the nearest year to that is 17 years, right? So 17 years. So I'm going to write 17 years is my solution. Now explain how your graph of AT confirms your answer. So this is what they want you to do. This is what they want you to do. They want you to find a million on the graph, and a million here is at 1,000. They want you to be like, oh, if I look, right, if there's a line here that represents 1 million, all right, where does it intersect, right? This my function here, and it intersects at 17 at year 17. So they make around a million years around year 17. So you can see it kind of intersects here. All right. So we can say how the graph confirms the answer is the graph of A of t, all right, crosses y equals 1,000, or if you wrote this in hundreds of thousands, right? Graph of y equals 1,000, right? You could have had your indents here at 100,000, and if you wrote 1,000, remember to clarify that you really means which means 1 million, where x, right? Well, not x, right? This is t, right? Let's be precise. Where t equals 17. All right, so that's kind of like how you explain, oh, look, it cross, they kind of intersect at y equals 1,000 with our function here. All right, so let's do June 19. All right, let's do June 19. Now it says Griffin is riding his bike down the street in Churchville, New York at a constant speed when a nail gets caught in one of his tires. The height of the nail above the ground in inches can be represented by the trigonometric function f of t equals minus 13,000 cosine 8 RT plus 13, where T represents the time since the nail first became caught in the tire. Determine the period of f of t. So again, the formula for period equals 2 pi over b, and that is, what's my b here is 0.8, so I'm going to get 2 pi over 0.8 pi, which is going to be 2.5. All right, so that's my period. So period equals 2.5. Circle that. All right, interpret what the period represents in this context, right? So there's many explanations you can give, and really a lot of times the way you explain it really depends on your grader when you take the regents, unfortunately, more than anything else, right? So they could be a very lenient grader and you could just explain one cycle, but well, some of the graders could be like, well, you have to specify, right, what's actually the function, measuring, right? So interpret what the context means, right? So we could say the period represents the amount of time, which is 2.5 seconds, for the tire to spin one full cycle. I can't spell. Cycle / rotation. All right, so you could write that. Some graders might be they might want really precise language, right? So you gotta write since the nail first became caught in the tire. So you have to add that part. Most graders are not like that, so I'll just leave it as is. All right. Now it's saying on the grid below, graph at least one cycle of f of t that includes the y-intercept of the function. All right, so let's break this down. We got to graph another trig function. All right. Okay, there's no legend here, so we're going to have to make a legend 2. So they want one period, and we know 2.5 is one period. So we're going to start at 0, and we're going to go all the way to 2.5, right? So many ways you could do it, right? So we could go up by, let's say, 0.5 every 3, right? So 0.5. Actually, let's find our interval first, right? I'm getting ahead of myself. So our interval equals the period times 1.4, which is 2.5 times 2.5 times 1.4, which is 2.5 over 4. And let's see what that is. 2.5 divided by 4. And that's 0.625. And that is our period, right? So maybe we can, use the period to graph. So let's do that. That's the proper thing to do. So maybe every 2 I go up by 0.625. So 0.625. So and that's going to be 1.25. So remember, we're going up every 3. So every 2. 1, 2. 1, 2. That's going to be 1.85. 1.85. No, I can't do basic math. So 1.25. So 1.875. And over here, this is going to be 0.875. plus 0.625, it'll be 0.24, so 2.5 right here. So 2.5, so that's going to give me one whole period. It's going to be one whole period. You can make it bigger, that might be better. All right. And now we have to look, right? Now we have to see our function and see how high it goes and how low it goes. And we have to look at, and the key to doing that is by looking at the midline, right? So let's find our minimum and maximum. So our maximum here is k plus a. So that's going to be 13 plus 13. And remember, a is amplitude. A is always positive. Even though this is negative, the amplitude is positive. So that's going to be 26. That's why a here is positive. Our minimum, which is going to be k minus a. Again, the amplitude is positive, so it's going to be 13 minus 13, which is 0. So we're going to go between 0 and 26. 0 at the minimum, and we're going to go all the way up to 26, right? So there's plenty of ways you could do this. Let's go by 2 each time. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'll go up to 28. Why not, right? All right. So we have everything we need to graph. A couple things we need to do. We kind of have to explain the legend here, right? So this is the height of nail. Through time. That could be the title, right? And this is height above ground. Y-axis height above ground. And let's specify that's in inches. And this is time. That's in seconds. All right. This is an S right here for seconds. All right. Now let's graph this, right? So this is a cosine, and so cosine, remember, starts at the top or the bottom. Let's draw the midline here, which is 13. This helps me make a dashed line here. All right, so cosine starts at the top of the line. It's a positive cosine function. It starts at the top of our cycle. If it's a negative cosine function, it starts at the bottom of the cycle. So you start at the minimum or the maximum, right? So because it's negative, we're going to start at the minimum, which is 0, 0, right? Which is 0, 0. So that's going to be my y-intercept, 0, 0, because they said, remember, that includes the y-intercept of the function. So 0, 0. At 6.25, I'm going to go to the middle of the graph, because that's what cosine functions do. After the first, if it comes from the top or the bottom, it goes to the middle next, right? And then after it goes to the middle, either goes to the top or the bottom, and this is a negative. So I'm going to go to the top, which is 26, my maximum here. And I'm going to come back at the next interval to my midline, and I'm going to end back here at the bottom, right? So I'm going to make a nice graph, right? Nice graph here, and that's one whole period. All right. Does the nail ever reach 30 inches above the ground? Well, let's take a look at our graph. Well, clearly not. The most it can go up is 26, right? Justify your answer, and you're going to be like, no, because the max height of the tire is 26 inches. And you can show that, right? You can show your work here, right? Which is over here, right? So you can put that down here, which right, you could show that the max Calculation equals K plus A, which is 13 plus 13 equals 26. All right? And that's the whole answer. All right, let's take a look at this problem, August 19th. I personally feel like this is a difficult problem. So let's get to it. It's a very long problem. It's a lot of reading comprehension. At least that's what I feel, right? You guys are smarter than me, so you could probably do it much more easily. So at the August 19th questions, the Beaufort wind scale was devised by the British Rear Admiral Sir Francis Beaufort in 1805. Oh my God. It's a long time ago. Upon observations of the effects of the wind. Beaufort numbers B are determined by the equation B equals 1.69 times the square root of S plus 4.45 minus 3.49, where S is the speed of the wind. All right, and B is rounded to the nearest integer from 0 to 12. All right, so the speed, like this is like this is like a wind scale, right? Some like the power of the wind or something determined by some function here. All right, so let's take a look, right? They give us a table here for the Beaufort number at the force of the wind. So at 0, it's calm, right? The wind is calm. And when the Beaufort number is 12, you're going all the way to a hurricane, which is bad, right? So don't be in a hurricane. All right, using the table above, classify the force of wind at a speed of 30 miles per hour. Justify your answer. So it's asking you to find the Beaufort number when the speed is 30 miles per hour. So this can be tricky. So maybe you want to do 30 equals the equation. No, you're going to set B, which is the Beaufort number, 1.69 times the square root of S. And S here is going to be 30, right? So we're going to do 30. We're going to replace this S here with 30 because it's 30 miles per hour plus 4.45 minus 3.49. All right, and that's going to give you some number. Let's put that in the calculator. All right, so I'm going to get 1.69 seconds x squared, which is going to be the square root, 30 plus 4.45 minus 3.49. And that's going to give me 6.4293, blah, 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 right? So that's going to give me B equals 6.4293. All right, and rounded to the nearest integer. Remember, B is rounded to the nearest integer, so this is 4. It rounds down, so this rounds to 6, right? And what is 6 here? 6 here is classified as a steady breeze, so we're going to say steady breeze, right? And that's our answer. So if it's 30 miles per hour, there's a steady breeze, right? If you got a windbreaker, that might be a nice feeling, or maybe you don't like the wind, right? And so on and so forth. So that's how you do that part of the problem. You gotta substitute 30 in for S, and then you gotta calculate round to the nearest integer and look at the chart and be like, oh, the nearest integer says that's a steady breeze. Let's take a look at the next problem. Next part of the problem. In 1946, the scale was extended to accommodate strong hurricanes. A strong hurricane received a B value of exactly 15, so it even goes above this scale, right? It goes to 15, and it's like a really strong hurricane. Algebraically determine S to the nearest miles per hour. So they're giving us 15, and they want us to find S. So what we're going to do here, now B, we know the value of B is 15. So let me change up the color here. So we're going to have, this color is too light. Let's try orange, right? For the next, right? So 15 equals 1.69 square root of s plus 4.45 minus 3.49. All right, now I want to isolate this s here. I want to know the speed here. I want to isolate this s here. So first thing we're going to do, we're going to add 3.49 to both sides. Plus 3.49. It's going to cancel out here, so I'm going to get 18.49 equals 1.69 square root of s plus 4.45. I'll go back to orange here. Now I want this s by itself, right? I gotta get the radical by itself first. To do that, I gotta divide both sides by 1.69. 1.69. All right. And that's gonna give you, let's just keep it in fraction form for now. So 18.49, because we want our answer to be as accurate as possible. 1.69 equals square root of s plus 4.45. All right, now I want the s by itself, so this is a square, so what I want to do, I'm going to square root both sides. I'm going to square root both sides to get rid of this square root. All right, so now I'm going to continue the work here. I'm going to get 18.49 over 1.69 squared equals s plus the square and the square root cancel out, 4.45. I want that s by itself, so all I have to do is subtract 4.45 from both sides. Right, so I'm going to get 18.49 over 1.69 squared minus 4.45 minus 4.45, let's specify here, equals s. So let's put that all in the calculator, and that will give us s, right? Go back to our calculator. Parentheses, alpha y equals n slash d. That gives me my fraction in my calculator. So 18.49 divided by 1.69, and the whole thing squared, minus 4.45, right? So that's going to be 115.25, blah, blah, blah. So 115.25, blah, 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 equals s. But I want the nearest miles per hour, so my answer is going to be 115.25. That's going to be my answer for that part. Now, let's take another look at the next part of the question here. And that is, any b values that round to 10 receive a Beaufort number of 10. Using technology, find an approximate range of winds to the nearest mile per hour associated with a Beaufort number of 10. All right, so now it's asking us, all right, we have an output, like the first part of the problem, which is 10, the second part of the problem, which is 10, and we want to find s, right? And it's asking us to use technology to find a range of winds, the nearest miles per hour, right? So let's do this. Let's set up the equation here. So my b is 10, and that equals 1.69 square root of s plus 4.45 minus 3.49. All right. So we can honestly, there's a couple of ways you could really do this problem. You could do it algebraically. You could brute force it as well. All right, let's try brute forcing it. So if you want to do the algebra, you just follow the same steps as part 2. So let's brute force it, right? So what values round to the nearest to 10, right? So what values round to 10? Okay, so the values that round to 10 are going to be between 9.5 and between 10.5, right? So these are the values that round to 10, so a little less than 10.5. So you could just kind of solve for this, right, using the calculator and so on and so forth. All right, so let's put this in. You can kind of backtrack this. You can look at the graphing calculator. All right, I take back what I said. Let's do this algebraically. And that'll give us the answer. Yeah, let's do it algebraically. Let's not do the calculator part, because that's might actually get a little more complicated, right? But the range here is between 9.5 and 10.5. That'll give us the range of values, right? All right, let's go back to this algebraically. All right, so again, same thing here. I'm going to add 3.49 to both sides. So it's going to be 13.49 equals 1.69 square root of s plus 4.45. All right, so divide both sides by 1.69 like last time. 0.69, this cancels out. All right, now I'm going to square root both sides. So the square root of 13.49 over 1.69 squared equals square root of s plus 4.45. All right, squared. All right. So now I'm going to continue the work here. This is going to be, again, same thing. Now I have 1.349 over 1.69 squared equals s plus 4.45. Subtract 4.45 from both sides. 4.45, and let's put that in the calculator. All right, let's go back to the calculator. All right, let's go back in the calculator and let's put this in. Actually, I'll put this back in and I'll just delete this 18.49. Delete. And instead of 18.49, I had 13.49, and everything else is the same. And I'm going to enter. So I get 59.266. So 59.266 and so on equals s. All right. So now you got to think about this logically, right? So 59 falls between what set of numbers here, right? What set of numbers falls between 59 and so if you want to think about it, right? If we divide, let's just estimate this to be about 60, right? 60 equals s, right? And remember, we want a value of 10 here, so we could divide by 10 here, and that's going to give me 6, right? So now this has nothing to do with s. This is just some chicken scratch work right here. And so I could say 6, and remember my values for the BF4 number are between 9.5 to like 10.5, right? So now I could multiply 9.5, all right, times 6 through 10.5 times 6, right? And that'll get me something like 57 through 63. And because we're rounding to the nearest miles per hour, right? What values will round to 60? What values will round to 60 miles per hour? Because it's asking us to round to the nearest mile per hours to receive a value of 10. So what values here round to 60? So the values between 55 through 64 round through 60. So we could say, and that goes close to our calculation, we can write here. This is a really complicated problem here. So 55, so the speed of the wind is somewhere between 55 s and 64. All right, so because it fell around 60 miles per hour, so we want to see what values fall between that round to 60, which 55 and up to 64 round to 60. So that's why we have that range, and that fell within, doing my chicken scratch work here, which is 57 and 60. So that was close. Maybe disregard the chicken scratch work, but that's the answer right here. We found our value to be 60, and we want to know what values round to 60, because that's what it's asking. They're asking us to approximate a range of winds that round to the nearest wind. All right. Let's do this January 2020. All right. Sarah is fighting a sinus infection. Her doctor prescribed a nasal spray and an antibiotic to fight the infection. The active ingredients in milligrams remaining in the bloodstream from the nasal spray, NT, and antibiotic, AT, are modeled by the functions below, where T is the time in hours since the medicine was taken. So I'm going to just write nasal here, and I'm going to write antibiotic here, because that will be helpful for me. All right. Determine which drug was made with the greater initial amount of active ingredient. Justify your initial answer, right? So remember, T is defining hours since the medication it was taken. So the amount of medication in you will be most potent. You'll have not the most potent. You'll have the most amount of medicine in your body as soon as you take it, right? As soon as you start digesting it, right? Before your body, really breaks it down and sends it through your bloodstream, right? So, so as soon as you take the medicine, how much time has passed? So no time has passed. So what you want to do here, when no time has passed, how can we say that? That's 0, right? So we're going to just plug in 0 for both of them. So we're going to find n of 0, and we're going to plug in 0 wherever we see t. So 0 plus 1 over 0 plus 5 plus 18 of 0 squared plus 8 times 0 plus 15. All right. And we're going to find a of 0, which is going to be 9 over 0 plus 3. Well, this one's easy. This is just going to be 3. We got to do some work here. All right. So let's put in our calculator. We have alpha y equals n slash d. That gives me my fraction. So 0 plus 1 over 0 plus 5. And the whole thing I'm going to add here is another fraction, alpha y equals n slash d. That's 18 over, 0 squared is 0. 8 times 0 is 0, so I'm just going to have 15 here. So what am I going to get? 1.4. So that's going to give me something like 1.4. So this is going to give me 1.4. And showing my work is justifying my answer here, right? So determine which drug is made with more active ingredient. So we're going to say, well, this one, the antibiotic, the antibiotic is made with more active ingredient because at t equals 0, 3 is greater than 1, right? Something like that, right? Something like that. You want to write something like that, right? Or you could say when you just take the medicine, the value of the antibiotic is 3, and the value of the nasal spray is 1.4, and 3 is greater than 1.4, so that means the antibiotic is made with more active ingredient. All right, so let's take a look. Sarah's doctor told her to take the drugs at the same time. Told her to take both drugs at the same time. Determine algebraically, so we have the algebra here, the number of hours after taking medications with both medications will have the same amount of active ingredient remaining in her bloodstream. So we have to do some algebra here. So what we're going to do is we're going to set both equations equal to each other. That will determine the time where they have the same amount of medication. So we're going to say n of t equals a of t, and that's going to be t plus 1 over t plus 5 plus 18 t squared plus 8t plus 15. That's going to equal 9 over t plus 3. All right, so we set them all each other. Now we have to solve, right, for the time, which is t. So this looks like a rational equation to me. So let me give myself a little more space. Oops, let me get back the eraser here. All right, let me change this back. All right, so this is going to equal, again, equal 9 over t plus 3. So this rational equation, we want to find the LCD, right? So we can cancel out the denominators. We want to multiply everything by the LCD, so the denominator is canceled out, and we can solve it easily, right? We don't like dealing with denominators. They make our life difficult. So first thing we want to do, we want to factor this expression right here, right? What are the factors of positive 15 that add up to positive 8? Well, I know my times table. Well, 15, the factors of 15 that add up to 8 are 5 and 3, right? 5 times 3 is 15, and 5 plus 3 is 8. So I could say this is the same as 5 plus 3, and t plus 5 and t plus 3 by factoring it. So I factored it, right? So you want to always factor the squared term if you have it when you solve a rational function. Well, lucky us, right? This is t plus 5 and this is t plus 3. All right, so now we're going to multiply everything by the LCD to cancel out our denominators. So let's do that. So t plus 5, t plus 3, same thing here. T plus 5, t plus 3, and same thing here. T plus 5 and t plus 3. All right. This will help us cancel all our denominators and make our life easy. So let's cancel out the denominators. So t plus 5 cancels here, the first term, and the whole denominator and the factors cancel out because both factors are present in the denominator there, and t plus 3 cancels out in the next term on the other side of the equation. All right, so now I have t plus 3 times t plus 1 plus 18 equals 9 times t plus 5. All right, so let's expand this, right? So this is going to be t squared plus 3t, all right, 3 squared plus 3t plus 1t plus 3 plus 18 equals 9t plus 45. Now we want to combine like terms. So this is t squared plus 4t plus 21 equals 9t plus 45. All right, the highest power here is 2. So I know this is a quadratic. So I'm going to move everything to one side. I'm going to minus 9t and minus 45 from this side. That'll help me set up the quadratic equation or factoring, right? Whichever I feel is easier. So minus 9t minus 45 from both sides. So this cancels out. I'm going to continue my work here. So I'm going to have t squared minus 5t minus 24 equals 0. All right, so now I'm looking at the factors of negative 24 that add up to negative 5. So some of the factors of negative 24 are, let's say, 12 and negative 2. But if I add those, that's not going to give me negative 5. So let's try 4 and 6, 4 and negative 6. But if I add 4 and negative 6, that's going to give me negative 2. So that's not going to work out. Now let's look at 8 and negative 3. 8 and negative 3. So that's going to be negative 24. But 8 plus negative 3 is positive 5. So maybe it's the other way around. So let's try negative 8 and 3, right? So that's going to get to negative 24, and it's going to add up to negative 25. So I can break this up into t minus 8, t plus 3 equals 0. All right? And so I'm going to solve, right? I'm going to solve for my zeros here. So this can be t equals 8, t equals negative 3. Well, I'm going to immediately reject this answer. Why? Why? Because t is time. I cannot have negative time. I don't have a time machine, right? I'm going to reject this, right? Reject this, right? Reject, right? And you can write why you reject, because you can't have negative time. You know, the jury's out on that for now. You know, we might get a time machine, well, maybe. So we reject that because we don't have negative time. So at t equals 8 is when they intersect. So you're going to write after 8 hours, the two drugs will have the same amount of active ingredient. All right, you want to circle that answer here. All right, and all right. All right, so let's take a look at the June 22 problem, question 37. The population in millions of people of the United States can be represented by the recursive formula. So this is a sequence problem, right? Recursive formula, where A of 0 represents the population in 1910, and N represents the number of years since 1910. Identify the percentage of the annual growth from the equation A of N equals 1.015 A N minus 1. So it's asking, right, like how much is it growing by, right? It's a geometric sequence, so let's get that off the bat, right? So it's asking how much is it increasing by, what's the rate is it increasing by, what percentage, right? So we can take a look at right here, right? Over here, as it says A of N, right? 1.015 A to the N minus 1, right? Let's take a look at this. And what is this? This is, if you multiply by 100, right? So if you multiply 1.015 times 100%, right? Because we're dealing with percentage, you're going to get 101.5 percentage. So the annual growth rate each year is not 101.5%. It's 1.5%, because in in our math class, we start at 100%. Everything starts at 100%. And you either go down a percentage, right? For the purpose of this class, right? You either go down a percent, so you're decaying, or you're losing value, or you're going up a percent, so you're growing, right? Or gaining value, right? So if we're, by that logic, if we're starting at 100%, we can see what the difference between this percentage, 101.5, and 100% is. So we can subtract 101.5% from 100%, and we get 1.5%, right? So that's our answer. Some of you might be tempted to be like, oh, I can see this off the bat. This is 0.15, right? This is 1.5, right? So that's okay. That's an okay answer, but make sure you add the percentage. But some of you might be like, well, it's 0.015. That's the difference. No, this is wrong. This is not a percentage at all, right? So that's not going to work. So make sure you read the word properly and you write down annual growth rate, the percent, all that's important of this function. Now, let's take a look at part 2 of the question. Write an exponential function p where p of t represents the United States population, millions of people, and t is the number of years since 1910. All right, so they want us to convert this into a exponential function, and you get the exponential functions as given to you the formulas, right? So this is we're going to use here is this first one, right? This is growing by a certain percentage, so a equals p. This is given to you 1 plus r over n to the n times t. All right, so we're going to convert that, right? We're going to put in those values. So what is a? What is p? What is the starting value? So this function is defined by p of t. So p of t equals, my starting value is 92.2, right? And how much is it growing by each percent, right? This number right here, 1.015 or 101.5%. So 1.015, that's your growth rate right here, to the power n times t, right? N here is 1, right? Because we're going up every year, so it's just 1t. But we wouldn't write 1t, right? We would just write t, right? Now, according to this model, the third part of the question, determine algebraically, so we can't use our calculator, we have to determine algebraically the number of years it takes for the population of the United States to be approximately 300 million people. Round your answer to the nearest year. All right, so it's saying my output is going to be 300, right? So, and we're going to use this formula that we just made, right, to calculate how many years it'll take, right? So this is like, this question, this part 2 weighs heavily because it's going to be used to solve part 3. So let's do this. So 300, which stands for 300 million people, equals 92.2 1.015 t. All right. So now we're going to divide both sides by 92.2. 92.2. All right, so we're going to get 300 divided by 92.2 equals 1.015 t. I want the t to the front. There are a couple of things I could do. I could log it, ln it. Let's just log it, right? So let's do log 300 divided by 92.2 equals t log of 1.015. All right, so we're gonna divide both sides by log. We want the t by itself. Log of 1.015 divide this side by log of, let's cancel out, 1.015. All right, and let's see what that is in our calculator. So let's clear this up. All right, so we have log of, well, this is a fraction, so my bad, alpha y equals n slash d. We have log of 300 divided by 92.2 over log of 1.015. Enter. So we got 79.24 years, right? 79.24 years. So t is going to be, well, 79.24. But they said, remember, they said to the nearest year. So this is going to round down. So this is going to be 79, t equals 79 years. All right. So I'm going to circle that, right? Or, make a box. All right, so that's June 22. That's how you solve it. All right, let's move on to the next problem. Oh, this is great. Another graphing problem. All right, so let's get started. A technology company is comparing two plans for speeding up its technical support time. Plan A can be modeled by the function a of x equals 15.7.98x, and plan B can be modeled by the function b of x equals 11.99x, where x is the number of customer representatives employed by the company, and a of x and b of x represent the average wait time in minutes of each customer. All right, so now it says graph a of x and b of x in the interval from 0 to 100. So we're lucky here. Everything's labeled, so we don't have to make a legend. We don't have to make the indents. We just have to follow the rules here, right? Just to follow the rules here, and we just have to graph it. So let's put both of these in the calculator and let's graph this thing. Calculator, y equals, clear. All right, so for a of x, and we're 15.7 0.98 to the power x, and for b, I'm going to have 11.99 to the power x. All right, and now I'm going to look at my table to graph. All right, or maybe I'm going to adjust my window here. I go from 0, my x is going from 0 to 100. Let me take a look at the graph too. And my y goes from 0 to basically 20. All right, I just want to see the graph, right? So it's supposed to look something like this. As we can see, it intersects somewhere between 20 and 40. And that might come in useful later, right? But this is what the graph is supposed to kind of look like. All right, so let's get to graphing, which we're going to need our table. All right, this is actually a lot of values, right? All right, so let's get started. So I think the best thing that you can do here is just use your graphing calculator and plot the points. So I'm not gonna do it as meticulously, right? I have the values in front of me. Just for the sake of time, I'm not gonna write everything out, but if you want, you can make a table here, x, and you have a of x here, and you're gonna have 0 because you start at 0, right? And you're gonna have 0 and 15.7, and the next place you would go to is 10. So you'd find the value of 10, and if you look at your table, it's going to be 12.8, right? And so on and so forth. Then you do the same thing with b. You'd do x, b of x, and you do the same thing. You start at 0, you'd get 11. You go to 10, you go 9.9. You go to 20, you go to 9. and so on and so forth. You know what, I'll just do it, why not, right? 30, 40, 50, 60, 70, 80, 90, 100. All right, so you don't have to do this. I'm just doing this for myself and clarity's sake, right? Because this helps me out. And I'm going to write the values here. So for, let's do b of x at 30, it's 8.1. So you're going to need to look at your table to do this. 7.4, 6.7, 6 at 60, 7 is 5.4, 4.9 for 80, 4.5 for 90, and for 104. All right, and for a of x, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so same thing here. All right, so 20 is going to be 10.5, 8.6, 7, 5.7, 4.7, 3.8, 3.1, 2.5, 2.1. All right, so let's use these values and let's graph this thing, right? I'm going to graph a of x first, right? A of x at 0 is 15.7, so somewhere between 15 and 16 right here. At 10, it's 12.8, so right below this 13 mark. All right, at 20, it's 10.5, so it's going to be 10, 11. At 30, it's 8.6, so almost close to this 9 right here, which is between 8 and 10. At 40, it's 7, so we got lucky there, whole number. All right. At 50, it's 5.7, so just below the 6 here. At 60 is 4.7, so just below the 5 here. At 70 is 3.8, so just below the 4. 90, sorry, 80 is 3.1 over here. Then I got 2.5. And finally 2.1, right? It says 0 to 100, so I'm not going to go past it. I'm going to connect the lines right here. And label what function this is. This is a of x. Make sure to label, all right? Do one function at a time. Don't try to graph both, or, you're going to be confused on what lines to connect. So we have a, let's do b, all right? Let's do b. So 0, and I'm going to start at 11, which is right here. 10, 9, at 10 is 9.9, so that's basically 10. We'll just put it at 10. All right. At 20, it's 9. It's 30, it's 8.1, which is basically 8. At 40, it's 7.4. So between 7 and 8. At 50, it's 6.7. So somewhere between 6 and 7. At 60, it's 6. At 70, it's 5.4. So a little above here, between 5 and 6. At 80 is 4.9, which is basically 5, so I'm just put it this 5. And 90 is 4.5, so in between 4 and 5. And at 100, it's 4. So I'm going to connect the dots. You see how I graph one at a time, right? And you can clearly see it intersects somewhere around here, like we saw it in our graph, right? So it intersects somewhere around there. So it intersects somewhere around there, and this is b of x. All right, to the nearest integer, solve a of x equals b of x. All right, so let's do this, all right? So there's a couple of ways you could do this. You could probably do this with the table, but let's do it properly, right? So you could do this algebraically, but we've done this algebraically. Well, let's see how to do it with the calculator. So let's, A of x equals B of x is where they intersect. So let's go to the calculator. All right, let's go to our graph right here, right? We graphed this earlier, right? So if you look, right, they intersect, right? You're thinking, oh yeah, I got this. It looks like, 34, but we can't be 100% sure because it kind of all looks like it intersects. So we're gonna have to calculate it. So we're gonna have to second trace, which is calc, and we go to intersection. So option 5, enter. So left bound, you want to be left of the intersection, which is left of where they intersect, enter. Right bound, you want to be right of the intersection, enter. All right, and that will give you the intersection. So the intersection is x is 35, y is 7.7, but we only care about the x, right? So the nearest integer is going to be x equals 35, and that's it. It didn't ask you, how to do it. But you could, if you really want to be specific, you could say second trace intersect, right? If you want to justify your answer, but this didn't say justify, this didn't say explain how, this didn't say algebra, so just finding where they intersect is okay using that method. All right, now determine to the nearest minute b of 100 minus a of 100. Explain what this value represents in the given context. All right, so it's telling you to look at subtract these values and see what they determine, right? So let's take a let's go to our graphing calculator and let's go to our table, right? Let's go to our table. Let's go to 100. Right? Let's go to 100. We go to 100. So A is 2.08 at 100 and B is 4.06. So now it's asking for the difference. So B of 100 equals 4.0264, and A of 100 equals 2.0812, and we're going to subtract this. All right, and that's going to, if you plug this in, this is going to be something like 1.9, which is, we're nearest minute, right? So not 1.92, so we get 2. But what does that mean, right? So this means, right, what does x represent? It represents customer service employees, right? So customer service employee. Why won't it let me use orange? All right. So it represents customer service employee representatives employed, and the function represents the average wait time. So you could say because we're calculating at 100, for 100 customer service reps, the difference, because we're subtracting, the difference, give me a second, difference in average wait time is 2 minutes. Right, and that's your answer, right? That's what that means in the given context. All right, let's take a look at January 23. It's a Newton's law of cooling problem. These can kind of get a little complicated. But if we just break it down, it is not that bad. All right, so let's take a look, right? T0 is the initial response, TR is the room temperature, R is the rate of cooling, and T is the time in minutes for the object to cool to temperature T, right? So it's saying Mark makes t-shirts using a hot press to transfer designs to t-shirts. He removes the press from the heats that it heats up to 400, right? The shirt at 400, so that's our initial temperature. So T of 0 is, I'm gonna write here, is 400, right? So this is 400. All right, the rate of cooling is 0.0735, 0.0735, and the room temperature is 75 Fahrenheit. All right, so using this information, write an equation. So we basically have everything, right? So our equation is defined by T equals the initial amount minus the room temperature, e to the RT plus the room temperature again. So we're gonna have T equals parentheses T of 0, which is 400, minus the room temperature, which is 75, e to the minus, my decay rate is 0.0735, so 0.0735 T plus 75, and you're done. If you really want, you can subtract this thing right here, and that's fine too. So you could also get 325 e to the negative 0.0735 T plus 75. This is also okay. Either answer is okay. All right, so now it's saying use the equation to find the temperature of the shirt to the nearest degree after 5 minutes, right? So now they're saying find the temperature after 5 minutes. So it's giving us the time T. So we're just gonna plug in 5 for T, right? So there's some temperature at time T. So we're gonna have 325 e to the minus 0.0735. Not T, right? We have 5, right? It's 5 minutes. So we're gonna replace T with 5 plus 75. All right. So, if you put this in the calculator, you're going to get something like 300.05, blah, 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 right? But we want to calculate to the nearest degree. So our answer is 300 degrees. All right, that's our answer. At the same time, Mark's friend Janine, right? So we got some new person going. Their name is Janine. It's apparently Mark's friend. Removes a hoodie from a press that heats the hoodie to 450. So she's also she's designing hoodies, right? And he's designing shirts. After 8 minutes, the hoodie measured 270 Fahrenheit. The room temperature is still 75 Fahrenheit. Determine the rate of cooling of the hoodie to the nearest tenth, right? To the nearest 10,000, right? So that's important, right? 10,000, right? So we gotta underline this here. We gotta keep that in mind. So now it's asking us to find R. They're giving us everything except for the rate of decay, right? So they're giving us the output, right? After 8 minutes, they're giving us the time, so that's 8, right? So let's break everything down, right? So T equals T0 minus TR e to the minus RT plus TR. All right, so let's plug everything in. So after 8 minutes, so this is my output, 270. So I'm going to say 270. All right, equals my initial temperature, 450, minus 75 is my room temperature, e to the minus R, but my T here is 8, yeah, all right, R8 or 8R plus 75. All right, so now let's solve this. So I'm gonna have 270 equals 375 e to the minus 8r plus 75, minus 75 for both sides. All right, that's the first thing you gotta do. All right, so you're gonna get 195 equals 375 e to the minus 8r. All right. So you want to get this r by itself. So we're going to divide both sides by 375. So it cancels out. 375. You're going to get 370. You're going to be left with this. You're going to bring it down. 195 over 375 equals e to the minus 8r. All right. So we're trying to solve for r here. All right, so let's do this. We're going to continue the work here. All right, so there's just like a lot of ways we could do this, and all the ways is kind of okay. So remember, we're isolating for r. We've done this plenty of times, so we can just ln it, right? So ln gets rid of e. So we're going to ln both sides. So we're going to do ln 195 over 375 equals ln e to the minus 8r. All right, ln and e cancel out. The exponent comes to the front. So ln of 195 over 375 equals minus 8r. All right, and now I'm going to have, I want this r by itself, so I'm going to divide by -8. So I'm going to have ln 195 over 375 equals, this is going to cancel out r, and this whole thing is going to be divided by -8. All right, so let's plug that into the calculator. All right, I don't know why I keep doing that, right? All right, so second quit. Let's clear this up. So I have a fraction here, so and I'm going to have ln 195 divided by 375, and the whole thing is going to be over -8. And I'm going to 0.08174, but I only want to the nearest thousand, so 10,000, so it's going to be 0.0817. That's the answer I'm going to get. So this is r is going to be 0.0187, and that is your answer. All right, let's go. Now they're saying the t-shirt and hoodie were removed at the same time. Determine when the temperature will be the same to the nearest minute. All right, determine when they'll be to the nearest minute. So they're asking us that we could do it a couple of ways. We could do it algebraically. We could also do it through the graphing calculator. Sorry, give me 1 second. Let's do this for the sake of time. Let's do this with the graphing calculator. All right, so first we're going to set the two equations equal to each other, right? So when Mark and Janine's, when they remove the t-shirt and hoodie, we're going to set these equations equal to each other. So we're going to have 325 e to the, that's Mark's t-shirt equation, minus 0.0735 t, all right, plus 75. 75 equals, now the equation for the hoodie is going to be 375 e to the minus, remember my r here, we just found this 0.0817 t plus 75. All right, so we can set these two equations equal to each other and see when they intersect. All right, so let's try that first. Let's go to our y equals. Let's clear this stuff up. First equation, well, it doesn't matter which equation, right? We're just looking for them to intersect. 375. Second ln, that gives me e to the minus 0.0817x. The next one is 325. Second ln, which gives me e minus 0.0735x. All right, and now let's look at our second table, right? All right, if you look at our table, right, seems like they kind of, right, let's look at the values. They kind of, let's go up to 20, because it seems like the values kind of intersect around 17 and 18. You see they're very, very close, right? So let's set up our window. We're gonna have 0. I'm gonna go up to 20. All right, and temperatures here, right? Let's go to 450. All right, graph. All right, so we see our intersection somewhere around here. So let's do the intersection calculation. So you're going to second trace. You go to option 5, which is intersect.
Got a pile of clothes you never wear anymore?
Oh my god.
Turn them into cash with Vinted.
What is this ad? I should really buy the app for $6. No, I don't want to get this. All right, please let me X this out. All right, close. All right, so again, left bound. I think I just have to left bound, so left of the intersection, so somewhere around here. And right bound, I'm going to go right of the intersection, which is going to be somewhere around here. Enter. And the intersection is at 17.4, right? 5, right? But they want us to the nearest minute, so it's going to be t equals 17.4, but it's actually, we want t equals 17, so 17 minutes. Again, if you want to justify this, right, you can write second, calc, or trace, and intersect. Right, that shows that, oh, I know how to find the intersection through the calculator. Because it didn't say algebraically, we could have done this algebraically. It would have been like some of the other previous problems we did, and we've done a lot of exponential problems, so that's fine. All right, now let's take a look at the next problem, which is June 23rd. All right, the volume of air in the average lung during breathing can be modeled by the graph below. Using this graph, write an equation for nt in the form nt equals a sine b of tx. All right, so there's a lot of stuff we need to digest, right, to figure this out. All right, first thing we're gonna have to do, right, let's find the top and the middle, right? So the top of the graph It's 2,000. So 1, 2, 3, 4, 5. So it's going up by 200 each time. So this is like 2,200, 2,400, 2,600, 2,800. I get to 3,000. So it's 2,800 is the top, and the bottom is 2,000. All right. So our amplitude A equals the maximum, right? It's the max minus min divided by 2. So that's going to be 2,800 minus 2,000 divided by 2, and that's going to be 400. So we got our amplitude A. All right, good. All right, now let's see our K, right? Our vertical shift, right? Because this obviously shifted from 0, 0. So to find C or K, which is our vertical shift, we can do C equals max plus min divided by 2, which is 2,800 plus 2,000 divided by 2, which is going to be 2,400. All right, so that is our vertical shift. Now we have to find B, right? To find B, we're like, well, how are we going to find B? First, let's look at the period, right? How long does one whole cycle take, right? This is a sine function. Once period of the sine function, it starts at the middle of the graph, which is right here, and ends again at the middle of the graph, which is right here. So one whole period is pi, right? So it's 5, right? So we can say period equals 2 pi over b. Remember, we're trying to solve for b here because we're trying to make an equation. So we have right here 5 equals 2 pi divided by b. I'm going to multiply both sides by b because I don't want the b at the bottom. This cancels out, so I got 5b equals 2 pi. So b equals 2 pi over 5. All right, so now I can make my whole equation. I have everything. So I have n of t, I got a different color here, equals, my a here is 400. Right, my a here is 400. Sine, parentheses, my b here is 2 pi over 5. 2 pi over 5 t, close parentheses, plus my vertical shift c, which is 2,400. And that's how you can find it using just the graph, all right, to find the trig function. All right. The same long when engaged in exercise is a volume that could be modeled by E equals 2,000 sine t plus 3,200, where ET is the volume in ml and t is the time in seconds. All right. Graph at least one cycle of ET on the same grid as n of t. All right. So they just want at least one cycle done. Okay. So yeah, all right, let's graph this thing, right? So to graph this thing, like they give us the function, it's all good, all nice. We have most of the information here. What we need now is to find the period, right? So the period here is 2 pi over b, and that's gonna be 2 pi over pi. That's going to be 2. So our period is 2. And remember, I want to find my interval here, right? So interval is going to be period times 1/4, which is going to be 2 times 1/4 equals 2 over 4, which is just, we could leave it at 2 over 4, right? It's just 1/2, right? We could leave it as 1/2, right? Reduce to 1/2. So we're going up by 1/2 each time, all right? So let's get to graphing this thing, all right? So remember, one whole period will take 2, all right? And each interval will be half. So I'm gonna mark this on this graph right here. So we're going off by 1/2 at a time. So half is here. There's another half here. Another half here, another half here, and that's one whole period, right? All right, So let's get started. So where is the middle of the graph? It's 3200. The middle of the new function is 3200, which is right here. So I'm gonna make some dotted lines. Be like, this personally helps me. So I know where the graph fits. All right. And now let's take a look, right? And it goes up and down, right? The maximum of the graph fluctuates between the middle of the graph and the bottom of the graph. So I'm just going to calculate the max here again. So the max for this one is going to be K plus A. All right, or C plus A. So I'll just write C because we're working with C here. C plus A. C is my midline plus my amplitude. And C here is 3200 plus my amplitude, which is 2000, which is 5200. And my minimum is C minus A, which is going to be 3200. Sorry, 3200 minus 2000, which is going to be 1200. There are just one too many zeros here. All right, so we're going to fluctuate between 5200 and 1200. So I'm gonna make some more dots here. So this is around 3200 because it's hard for me to see in this one, and this is 5200. So we'll be oscillating between those points. All right, this is a sine function. So sine function always starts at the midline, right? So the middle of the graph. All right, so at the middle of the graph, I'm going to be at this. I'm gonna graph this function e of t. Let me do it in green so it stands out. So I'm gonna be at the middle here at 0. And my next interval, which is half, I'm gonna be at the top of the graph because of positive sine function. So the top. All right, my next interval at 1, I'm going to go back to the middle. And now I'm going to go descend to the bottom because of the sine function. And 1 whole is going to be, right, voila, right, at least 1 whole period. Remember, I said at least 1 cycle. All right, so I graph 1 cycle, right? So how many times during the 5-second interval will n of t equals e of t, right? So they're saying when will the graphs intersect? So I already found it. Why are you not working? All right, over here and over here. All right, so I already found those 2 points, right? But that's only from 0 to 2. I want from 0 to 5, the whole 5-second interval. So I think I'm going to have to graph a little more, right? All right, that's just unfortunately what's going to happen, right? So every half, right? So I'm going to, until I go to 5, right? So I'm going to indent again. I'm going to keep graphing to see how many intersects I get. All right, so now next interval, I go to the top, go back to the middle at 3, bottom at 3.5, at 4, 4.5, I go to the top, and at 5, I'm back in the middle. So I'm going to graph this again. I'm only doing this to solve the next problem because they want to know how many times it intersects, all right? So what do you find? 2 intersections. Damn it, work. Right, and then it intersects 1 again here and once again here. So it intersects 4 different times, right? 4 different times, 4 times, right? And you can be like, check, graph, right? To show how you saw it, right? So if you do it like that, you can see it intersects 4 times and you're done with the whole problem. All right, I didn't think that was that bad. All right, so let's go to the next part. No time to waste. This is August 23. This is about the Manford family. Started savings accounts for their twins, Abby and Brett, on the day they were born. They invested $8,000 in an account for each child. Right? Abby's account had 4.2% annual interest compounded quarterly, and Brett's account had 3.9 annual interest compounded continuously. I guess they were doing an experiment or something. I don't know why you give them two different accounts, but whatever. I'm not their parents. Write a function AFT for Abby's account and a function BFT for Brett's account that calculates the value of each account after T years, right? So they want you to make two functions, AFT for Abby and BFT for Brett. All right, okay, another exponential problem. All right, so let's do AFT. AFT, right? Abby's annual interest compounded quarterly, right? So again, you get this formula in your formula sheet. The formula here is A equals P to the 1 plus R N over N times N times T, right? So let's plug that in, all right? And Brett's account is going to be this other one. The word continuous is here, so we have to use E, right? So it's going to be A equals PE to the RT, right? So let's keep that in mind. These are given to you on the formula sheet. I'm just writing it because I have it memorized. So let's use this and plug in the equations, right? So A of T equals P, which is the starting value, which is 8,000, right? They're both starting with 8,000. Parentheses, 1 plus R. My rate here is 4.2, right, percent. But I don't want percent, so I'm going to divide 4.2% by 100%. And that's going to give me 0.042, right? I want a decimal here. 0.042 over compounded quarterly. Quarterly. There's 4 quarters in a year. That's my N. 4. All right? 4 here. To the N times T. Again, N is 4. T. And that's A of T. Let's do now Brett's. Brett's is going to be a little easier. B of T. I have P, which is 8,000. E, right, because it's continuous, to the RT, right, 3.9%. I don't want 3.9%. I want a decimal. So, again, 3.9% divided by 100% equals 0.039. 0.039. All right, T. And that's it. That's both functions. Now saying determine who will have more money in their account when the twins turn 18 years old, and the difference in the amount of the accounts in the accounts to the nearest cent, right? So they want to know what the values are at 18. So, we can just plug this in the calculator. So you're going to plug this in the calculator for, now we know our time, which is T is 18. So let's find let's find Abby's first. So let's keep it color coded. So we're gonna have 8,000. 1 plus 0.042 over 4 times 18. And then Brett's, same thing, right? So you're gonna have B here, maybe A here, right? So B here. So you're going to have 8,000 e to the 0.039 times 18. All right, so you want to put that in the calculator, all right? You're going to put that in the calculator. This is what you're going to get. You're going to get here for Abby, you're going to get 16,970.89992. And for Brett, you're going to get 16,142.27394. All right, so you can clearly see Abby has more money in her account than Brett. So let's subtract them, right? So let's do some subtraction here and see the difference in accounts. So 16,142.27394, right? So if you subtract these, you put them in your calculator. All right, I'm gonna put them in the calculator off screen because that feels better than just going back and forth. All right, we're gonna get about $828.63, right? Because it says to the nearest cent, so we're rounding to the nearest cent right here. So who has more money? Abby's account has $828.63 more, right? So that's our answer with a trapezoid. All right. Now algebraically determine to the nearest tenth of the year how long it would take for Brett's account to triple in value. Oh man. Okay. So Brett's account, right? How much does it start at? Starts at 8,000. What's triple of 8,000? Right? So we're gonna do 3 times 8,000. It's gonna be 24,000. So now I know my output. Now I'm gonna find how many years it'll take for her account to triple. And I have to do it algebraically. So I'm gonna set 24,000 equals Brett's account equation, e to the 0.039t. All right. Algebraically, we want to get the t by itself. That represents time. We're going to divide both sides by 8,000. All right. And we get 3 equals e to the 0.039t. We're going to ln both sides. That gets rid of the e. We're going to continue our work here. ln 3 equals ln e to the 0.039t. So ln 3 equals 0.039t ln e. And ln e is just 1, so it cancels out, right? And I want the t by itself, so I'm going to divide both sides by 0.039. So 0.039. Let's put that in the calculator. All right. Again, I'm using the calculator off screen for the sake of time. And we're going to get something like 2.82 to the nearest tenth equals t, right? So at 28.2 years it will take for her account to triple. All right, so that's our answer. Oh, another wonderful graphing question. All right, so let's get to it. A manufacturer of sweatshirts finds that costs fluctuate depending on the number of products created. Creating more products doesn't always increase profits because it requires additional costs, such as building a larger facility or hiring more workers. The manufacturer determines the profit P of X in $1,000 as a function of the number of sweatshirts. X in thousands. The function P is given below. P of X equals minus x cubed plus 11x squared minus 7x minus 69. Graph Y equals P of X over the interval 0 and 9. All right, some key things here that we have to look out for. Remember, in thousands of dollars. Let's keep this in mind. Thousands of dollars. So I would underline that. All right, now it's telling us to graph it. All right. We all know what to do. All right. So I'm going to go to the graphing calculator. Y equals, clear this up. So I have negative x to the 3 plus 11 x squared minus 7x, delete, delete. All right, 7x minus 69. All right. Okay, so let's check our window before we even graph it. We just want to graph from 0 to 9. Clear, right? 9. All right, 9. And what are our values? The graph is kind of given, so it's at 30. And it doesn't go higher than, if you kind of estimate, maybe like 200 or something, right? Something like that. So top it below, right? So y, let's just look at our table instead of me guessing, right? So from 0 to 9, let's look at our values. At 0, I'm at minus 69, so that's like minus 70. And at 9, I'm going all the way up to 30, but it looks like I hit my maximum somewhere around here. So maybe I'll go shoot a little above. Maybe I'll do like 90, right? So let's set our window to minus 70. Negative 70 to 90 and see how that looks, right? So our thing looks something like that, which is not bad. All right. Okay, we just want to graph from 0 to 9. All right. Let's go back to our thing. All right. So again, you can do this. It's easier for you. I have to go back and forth between the calculator and what I see. So that's why I've been writing down the values here, right? So I have x, p of x, right? From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Just going to go back to this thing here, to my table. Just 1, 0 through 9. All right. Okay. Now that I have this, all right, so I'm going from negative 69, negative 66 at 1, at 2 is negative 47, 3 is negative 18, 4 is 15, 5 is 46, 6 is 69, 7 is 78, 8 is 67, and 9 is 30. All right. So, just got to start graphing here, right? So every 2 indents is 30. So this is going to be 60, and this is going to be 90. And this is going to be negative 30, and this is going to be negative 60, and this is going to be negative 90. So 1, 2, 3, 4, 5, 6, 7, 8, 9. They don't want us going above 9, so we're stopping at 9. So let's start graphing, all right? All right, that's not working. I don't know why. At 0, it's negative 69, so I'm somewhere around here. At 1, it's negative 66. So at 1, negative 66. So somewhere around here. At 2, it's negative 67. Sorry, it's negative 47, not negative 67. And negative 47 is going to be somewhere around here. At 3 is negative 18, so it's going to be somewhere around here. At 4, it's at 15. Finally, we're getting to some profits. It's over here, right? 15 is halfway between 0 and 30. And 5 is at 46, so a little above this 45 mark here. At 6, it's at 69, so somewhere around here. At 7, it's at 78. All right, so a little above here. At 8, it's 67, so we're kind of back here again. And at 9, we're back to 30. So here. And now let's connect the dots. So All right, we graphed it. Great. That's 2 free points if you graph it legit like this on the regions. Over the given interval, state the coordinates of the maximum P and round all values to the nearest integer. Explain what that means in terms of sweatshirts sold. All right, so let's take a look. We have our table here, and what's the highest value, right? It wants the maximum, so that's the highest value. So at 7, it's 78, right? It's 78, and it says coordinates. So I'm going to write the coordinates here are 7, 78. So at 7, 78, what does that mean in terms of the problem, right? Let's see what it says. P of X is the profit in thousands of dollars, and X is the number of sweatshirts sold in thousands. All right, so this means if 7,000 sweatshirts are being sold, then the profit is maximized at 78,000. That's what that means. All right, now let's take a look at the part. Next part. Determine how many sweatshirts to the nearest whole sweatshirt the manufacturer would need to produce in order to make the first positive profit. All right, let's take a look at the graph, right? Let's take a look at this graph right here. So profit, right? If I'm in the negative numbers here, I'm not profiting. So only when it crosses around this threshold do I start being in the positive, right? That's positive value. That's positive profit. Negative profit is just debt, right? So we need to use our calculator for this, right? So let's go back to our calculator and let's go back to our graph, right? And we're going to click trace here. Trace here, right? So let's go to the 0. Where does it 0? Where is y 0? When y is 0, that's kind of when I'm crossing the threshold. All right? That's when I'm crossing the threshold. Of when I'm going to make my profit, right? Because right below where y equals 0, that's in the negative profit direction. So you could do it a couple of ways. So you could find the 0 here. So let me just show you. You go to second trace, which is calc, and you can find the 0 here too, right? So you could be left of the 0, which is between 3 and 4. So you're going to hit enter, and then you're going to go right of the 0, which is enter again. And you're going to get 0 equals 3.54884. So we're going to go back to our calculator, right? So we're going to get 3.54884, something like that, right? So again, we want to the nearest whole sweatshirt, right? So remember, this is in thousands. I have to multiply this value by 1,000, right? It's in thousands of sweatshirts, right? So this is going to be 3,548.84, and it says to the nearest whole sweatshirts. So this is going to round up to 3549 sweatshirts, right? Sweatshirts to turn a profit. All right, to turn a profit. All right, and you can write because that is when the profit has positive values. So something like that to justify your answer. All right, so That's how you would do these questions, right? A lot of these questions, they're kind of just, there really are a lot of, there's math, but there's a lot of reading comprehension to decipher what is going on. All right, let's take a look at June 24th, problem 37. Megan is performing an experiment in a lab where the temperature is a constant of 73 Fahrenheit and the liquid is 237 Fahrenheit. 1.5 hours later, the temperature of liquid is 112. Newton's law of cooling states the temperature at some time t equals T of A, which is the air temperature or the surrounding temperature, or the room temperature, plus the initial temperature minus the room temperature multiplied by e to minus kt, where k is the constant. All right. Now saying determine k to the nearest thousandth for this liquid. All right. So let's break this down, right? So for the first part of the problem, we know the temperature at some time t is going to be 112 degrees, right? And that's going to be 1.5 hours later. So our t will be 1.5. All right. The temperature around the room, the air temperature, is at a constant of 73. So that's going to be 73. And our initial temperature is going to be 237. This is what's missing. This is what we have to find. So another exponential problem, and we're just going to break this down. 112 equals 73 plus the initial temperature, which is 237, minus 73, e to the minus k. Remember, we're trying to find k, and my t here is 1.5, right? 1.5. Let me write that a little neater. 1.5, right? All right. So first thing you do, you subtract the 73, right, from both sides. We look at this k by itself. That's the ultimate goal. We got to remove everything first. So it's going to give you 39 equals 164. That's 237 minus 73. E to the minus 1.5 k. All right, now you're going to divide both sides by 164. Because again, we're trying to isolate k. This is going to cancel out, so you're going to get 39, 164 equals e to the minus 1.5k. Now to get rid of e, we have to use the ln operation. So let's ln both sides. All right, so we're going to get ln 39 over 164 equals, and when you ln or log something, the exponent comes to the front, minus 1.5 k ln e. ln e is just 1, so we're just going to cross it out. There's no reason to have it there. I'm going to continue the work here. All right. So I'm going to have ln 39 over 164 equals minus 1.5k. I want the k by itself, so I'm going to divide both sides by minus 1.5. 1.5, and that'll give me k, right? So that'll give me k. All right. So we're going to put this in the calculator real quick and see what we get. So alpha y equals, right? On the top, we're going to have ln 39 divided by 164. And on the bottom, we're going to have negative 1.5. Let's see what we get. That's 0.957, but they want it to the nearest thousandth, so that's going to be 0.958 is going to be K, and that's our answer. We're going to circle or box it up. All right. Now we have K. Determine the temperature of the liquid using your value K to the nearest degree after 2.5 hours. All right. So now they're giving us the time. They just want to know the temperature. So this is just a simple plug in the calculator trick, right? So we're going to have T at 2.5, because it says 2.5, equals 73 plus 237 minus 73 e to the minus 9.58, because we found K to the 2.5. And all you have to do is plug this in the calculator, and that's it, right? So for the sake of time, I'm just going to do it off screen, and you're going to find that this amount is 88 degrees, right? So that's my answer. All right, this is you're just plugging in the calculator. You're not doing anything else for this problem. The next problem, let's take a look. Megan needs the temperature of the liquid to be 80 degrees to perform the next step in her experiment. Use your value K to determine to the nearest tenth of an hour how much time she must wait since the experiment first began. All right, so this is giving us the output. All right, now this is giving us the output, 80 Fahrenheit, right? And it wants us to find our time T, right? We have K. Remember, we found K, which is 9.58, and we're going to use that to find how much time it'll take for the thing to get down to 80 degrees. So our output is 80, and we're going to equal it to our equation here, 73 plus 237 minus 73 e to the minus 9.58. Okay, T, right? Okay, so we're gonna subtract 73 from both sides. Now we want to isolate T, right? Remember the first part of the problem, we were isolating K. Now we're isolating T. So like same exact steps, pretty much, to get to the answer. So 7 equals 164 e to the minus 9.58 T. All right, divide both sides by 164. We want to get this T by itself. It's going to cancel out. 74. So 7 over 164 is going to e to the minus 958 T. We're going to ln both sides to get rid of the e. So ln 7 164 equals, remember, the exponent comes to the front when you ln or log something, minus 9.58 T ln e. This is going to cancel out because ln e is just 1. And now I'm going to divide both sides by negative 9.58 to get this T by itself. Negative 0.958. All right, so all you have to do is plug this in the calculator. All right, and you're going to get something like, if you round to the nearest tenth, you're going to get something like, I'm going to do this off screen, 3.1. 3.3 equals T, so it'll be 3.3 hours, right? So, right, that is my answer. Okay, same thing. So part 1 of the problem, finding K, and part 3 of the problem, finding T. Same steps, it's just we're solving for a different variable. All right. August 24. All right. Oh, an interest round. More, yay, more exponentials. All right. Let's break this one down. Taylor wants to open an investment account with the $1,200 she received for her birthday. She narrowed her choices down to two banks. America's Bank offers 6.4% annual interest compounded quarterly, and Barnyard Bank offers 6.35% compounded interest compounded continuously. Right? Write functions AT and BT to represent her investment, with America's Bank and Barnyard Bank as functions of time, T in years. So America's Bank is A of T, so let's color code it. 6.4 annual interest compounded quarterly. All right, so again, this is going to use this equation here, the interest equation. A equals P 1 plus R over N to the T. Okay, that's what that one uses. You get that on the region, so you don't have to memorize it. All right. And then Barnyard Bank. No, work. Why are you not working? All right. And Barnyard Bank, which is B of T, 6.35% annual interest compounded continuously. When you see that word continuously, you use the variable E. So this is going to be in the format of A equals P e to the RT. All right. So let's find A of T and B of T. So A of T equals, my starting value is 1200. That's my initial principal value. 1 plus my interest rate is 6.4%. If you divide that by 100, you're going to get 0.064. So 0.064 over 4. And times T, 4 because it's quarterly. So I'm dividing by 4, that's my N. And to the N, which is 4, and to the time T. That's A of T. All right. And B of T for Barnyard Bank is going to be, again, 1200 is the initial amount. E to the, if you divide 6.35% by 100% to get the decimal, you're going to get 0.0635 T. And that is the equation for Barnyard Bank. All right. Now, you could simplify A of T if you want. You don't have to most of the time. And you calculate if you want. Okay. So, let's... let me show you what I mean. Right, you could write this. You could write that equals 1200. And if you add this inside together, you're going to get 1.0164T. So either answer is acceptable, right? Either answer is acceptable. Okay, let's take a look at the second one. Taylor would like to invest $1,200 into one bag for 10 years with no additional deposits and no withdrawals. Which bank will Taylor earn the most money? Justify your answer. All right, so this is just a simple plug and play, right? So we're just going to put in 10 to find our answer. So we're going to have, look at A of 10. A of 10 equals 1200, 1.016, 4 times 10. So that's going to be 40. And let's plug this in the calculator, right? I'm going to do this off screen. And this is going to be 2264.28. And now let's take a look at B of 10, which is going to be 1200 e to the 0.0635 times 10. And if you put that in the calculator, you're going to get another amount. You're going to get something like 2264.43. All right. So she ain't making, she's making more money in Barnyard Bank, but it's not a lot, right? It's 15 cents, right? So she should, but it's still more money. So you'd write, she should, we don't know if it's a she, so let's write. Taylor could be a boy's name, right? Taylor should choose Bank B, right? Bank B, or Barnyard Bank, which is Barnyard Bank. Okay. So let me capitalize that Barnyard, right? Is the name. All right. Let's take a look at the next problem. Taylor chooses to invest her money into Barnyard Bank. Algebraically determine how long to the nearest tenth of the year it will take her initial investment to triple, assuming she makes no deposits or withdrawals. All right. So, we at Barnyard Bank, you start at 1,200, right? And if it's going to triple, you're going to multiply by 3. It's going to be 3,600. So that's my new output. And I'm going to set it equal to the equation and find how much time it takes in years. All right. So we're going to have 3,600 equals 1,200 e to the 0.0635 t. I'm trying to find how much time t will take. First thing I'm going to do, I'm going to divide both sides by 1,200. I want to get the t by itself, so I have to isolate everything else from it. So I'm going to get 3 equals e to the 0.0635 t. Okay. And I'm going to change color, and I want to get the t by itself, so I'm going to ln both sides. I'm going to ln 3 equals, remember the exponent comes to the from when you ln something, 0.0635 t ln e. ln e is 1, so it cancels out. And I'm going to divide both sides by 0.0635 to get the t by itself, 0.0635. This cancels out. I'm going to get, if you put that in the calculator, you're going to get, and if you round to the nearest tenth, which is actually the nearest tenth of the year, you're going to get 17.3 equals t. So it's going to take 17.3 years, all right? And that's my answer. So I'm going to box it up. All right, let's take a look at January 25 with the honeybees. Oh, great. Another exponential problem. Wonderful. All right. Okay, let's get started. All right. The population of honeybees in 2 different colonies are studied for 4 months. During this time, the colony population can be approximated by PT equals P0 e to the RT, where PT is the colony population of bees at T months, P0 is the initial population, and R is the growth rate. All right, so colony A has an initial population of 10,000, all right, and a continuous growth rate of 0.25, so continuous growth rate of 0.25. And then colony B, initial population of 6,000 and a continuous growth rate, so these are the important keywords. It's 0.45. Write functions for AT and BT that model the honeybee populations of the colonies after T months. All right. So we just have to make these equations again. Okay, so we're going to A of T equals, the equation we have to use is because of the word continuous. We use this equation, which is given to you on the regis. A equals P to the RT. All right, that equation right there is what you're looking for. All right, so my initial value here is 10,000. All right, e to the 0.25t. That's it. I'm done. And then b of t, all right, is going to equal 6,000 e to the 0.45t. Now it's asking you to graph AT and BT between 0 and 4. They have everything labeled, the legend and everything, the axes, so you don't have to do anything. When you go to your window, you should change your window to this amount, and you should put it in the calculator and see what you get. All right. Okay, so let's do this, right? For the sake of time, I won't delve deeply into this as much as possible, as I've done with the other graphing problems. But just want to show you how to set it up. Oops. So at least let's take a look. Let's go to y equals. Let's clear this up. A of t is 10,000. Oops. Delete. E to the 0.25 x, and b of t is 6,000 e to the 0.45 x. And remember, my window, I'm only going from 0 to 4. That's my axis. And my y starts at 0 and it goes all the way to 50. All right, so now you want to click graph. Oh, what's going on here? Sorry. Why doesn't it look right? Remember, even though it went up to 50, it's in thousands. So it's not going to be 50, it's going to be 50,000, right? That's why I don't see anything. All right, so that's what it's supposed to look like. All right, your graphs are supposed to look something like that. And you can clearly see they intersect at some time here. Looks like a little above 2.5, right? So if we're tracing, you can see that it's like almost 2.6 where they intersect, right? Or 2.55. We'll keep that in mind later. All right. Using these values, you want to look at your table and then graph from 0 to 4. All right. So let's go back into it. So let's graph A of t. Using the values, you get a value at 10,000. At 1, you get a value over 12,000. At 2, it's a little over, it's like 17,000. At 3, it's a little above 20,000. And at 4, it's at like almost like 27,000. So this is gonna be like somewhere around here. So we're gonna connect the dots and make sure you label this as A of t. All right, or people are not gonna know what are you graphing. All right, and now let's graph B of t. B of t starts a little lower. All right, it starts at 6,000. 1, it goes up to about 10,000. Yeah, goes up to almost 10,000. Oops. At 2, it goes up to around 12,000. At 3, it goes a little above 20,000 over here. And at 4, it goes all the way up to like 35, 36,000. So like over here. So you want to connect these dots. I'm not an artist. So that's B of T. Okay. All right. State to the nearest tenth of the month when colonies will have the same population. So there's plenty of ways you could do this. You could do this graphically, finding the intersect option when you go to second trace, which is second calc intersect, and you choose option 5, which is intersect. All right, but let's do this for absolutely no reason. Let's do this algebraically because, why not, right? All right, so we're going to set to find when they have the same population, we're going to set the equations equal to each other, all right? So we're going to set 10,000 e to the 0.25 t equals 6,000 e to the 0.45 t. All right? All right, so first thing you want to do, remember we're solving for t, so we want the t's on one side. So we're going to divide both sides by e to the 0.25 t. E to the 0.25 t. So this is going to cancel out. All right? This is going to cancel out. So I'm going to get, this is just 1. 10,000 equals 6,000 e to the, remember, now we have the same variable. All right? And they're different powers, top and bottom. What do you do then when you're dividing same variable with different powers? You subtract the power. So e to the 0.45 t minus 0.25 t. Remember, we're trying to isolate for t, so we're going to divide both sides by 6,000. All right. Okay. All right. So that's going to give me something like 5/3 equals e to the 0.45 t minus 0.25 t is e to the 0.25 t. Sorry, not 0.25, 0.2 t. All right, to get rid of this e, I have to ln both sides. So I'm going to do ln 5/3 equals 0.2 t ln e. ln is just 1, so it cancels out. I'm going to continue the work here. All right, so ln 5 divided by 3 equals 0.2 t. All right, now I'm going to divide both sides by 0.2 because I want the t by itself. Now, if you put this all in the calculator, you're going to get something like 2.55, but it says round to the nearest tenth, so that's going to round to 2.6, so we're going to get 2.6 equals t. All right, and that's your answer. And for the next problem, determine algebraically how long it'll get to the nearest tenth of the month for the population in colony A2 triple. All right, so colony A starts with 10,000, and we want it to triple, so it's 10,000 times 3 equals 30,000. All right, now that's our output, and we want to see how much time it'll take for it to triple. So we're going to be like 30,000 equals 10,000 e to the 0.25 t. Again, same exact steps, right? So 10,000 divide both sides by 10,000. we're going to get 3 equals e to the 0.25t. Kind of almost done here, right? And we're going to do ln 3 equals, exponent comes to the front when you ln something, 0.25t, ln e, which just cancels out. All right, so I'm going to continue the work here. Ln 3 equals 0.25 t. Divide both sides by 0.25 to get the t by itself. All right, so you're going to get something like to the nearest tenth, if you put it in the calculator, 4.4 equals t. All right, that's your answer. Okay, all right. So not bad. A lot of exponential problems. And the next one is also an exponential problem. Why are they all exponential problems? Anyway, I guess this is the most useful thing you'd learn in Algebra 2, right? I'm being honest, the exponential growth and decay and probability is important just for real life stuff. And trigonometry, if you're going to do something with being an engineer, yeah. So I guess a lot of it's important. All right, so let's take a look at this problem. CCM 130, June 25th, question 37. CCM 137 decay can be modeled with the formula AT equals A0 e to the KT, where AT represents the mass remaining in grams after 2 years, and A0 represents the initial mass. A sample of 500 grams of cesium 135 takes approximately 6.34 years to decay to 125 grams. Use this sample with the given formula to determine the constant K to the nearest thousandth. All right, so this is giving us the general formula, so let's just use the general formula, right? AT equals A0 e to the KT. All right, so AT is going to be my initial amount, all right, is 500, all right, 500, okay, E, all right, to the I don't know my constant K here, so I'm going to put in my variable T, 60.34K, 60.34K, and that's going to equal, and it's going to take 60.34 years to hit 125 grams. So we're using that to find our value K here. So again, same things, right? We want to isolate this value K here, divide both sides by 500. All right, so we're going to get something like e to the 60.34 K equals 0.25. All right, now we're going to ln both sides to get rid of this e, so we're going to get 60.34 K ln e equals ln of 0.25. ln e is 1, so we can just ignore it. And now we're going to divide both sides by 60.34. 60.34. And let's put this in the calculator. And it says to the nearest thousand, so we're rounding to 3 decimal places. So you're going to get something like K equals negative 0.023. All right, so that should be your answer. Use this value for k to write a function at that will find the mass of 500 gram sample remaining after any time t in years. So we have a of t equals, all right, so we're now making the general formula, all right, 500, which is my initial amount, e to the, now we have the decay rate k, which is minus 0.023 to the time t. Remember, before in the first part of the problem, it was giving us a certain time t, which is 60.34 years, and it took that much time to get to 125 milligrams of grams of cesium-137. But now we're just making a general formula to find it at any time, whether it's 1 year, 1,000 years, 200 years, it doesn't matter, right? That's why we have t instead of 60.34. And that's my formula. Now it's saying graph AT on the graph below from t equals 0 to t equals 150. All right. So this is an absurdly tedious problem, but let's do it anyway, right? So we're going to grow from 0 to 150. Let's see how it's spaced. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we could start off here, stop here. That could be 150. 150, this could be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. So we're only going up to 150, right? And we're starting, our starting value is 500, right? And we found that this function has a decay rate, right? It's going down. The rate is negative 0.023, so it's going to decay. So 500 is going to be my maximum value, and I'm going to keep going down from that, right? So, maybe every 4 spaces I'll do 100, 100, 200, 300, 400, and 500. Remember, so 500 is the starting value. It's a decaying function, so it's just going to get lower. All right, so now what we want to do is put this in the calculator and kind of get an idea of the values and what they look like. So let's go to our calculator here. Oops. Y equals, let's clear this stuff up. So my function here is 500 500 e to the negative 0.023 x. Let's check our window. 500 is the maximum. The x maximum is 150. All right, so let's graph that, right? Okay, so it's going to look something like this, and maybe we'll only count every 30, right? Every 30 or something. Yeah, so the values at every 30 will record, right? So you want to go to your table, and this is tedious, right? You're going to start at 500, you're going to have to go all the way to 30. All right, so 30, and that's going to be 250. So I'm going to have, okay, x, at, 0, that's 500. 30, that's like 250. I'll just keep going up by 30. 60, 90, 120, 150. All right, so let's graph this. So at 0, it's 500. At 30, it's about 250. So it's about halfway between 300 and 200. Let's check the values at 60 and 90. Okay. At 60 is about 125. So 60 is 125, and 90, it's about 63. So 125 and 90, it's 63. All right. So at 60, we're going to go to 125, which is around here. And around 90, it is 63. So it's just a little, like somewhere around here. All right. Now we just got two values at 120 and 150. So let's check them out. So at 120, the value is 31. And at 150, the value is 15. So 31 and 15. So 31 and 15, right? Okay, so at 120 is going to be 31, which is going to be somewhere around here. And at 150, it'll be 15, which will be somewhere around here. Now I'm going to connect these dots. All right, no arrows because it's on a given domain. All right. And that's the whole graph, right? That's how you graph it. That's how it should be graphed properly. Just don't guess on the graphing. I'm using estimates here, right? So, I'm just using estimates here to graph this properly. Because, you don't just want to make like a general line of the shape. That's just completely wrong. All right, now it's saying use A of t to calculate the average rate of change in grams per year for t of 0 and t of 60 to the nearest tenth. So this is asking for the average rate of change. So this is going to be the change in y over the change in x. And how do you find that? That's y2 minus y1 over x2 minus x1. All right, so we know the x values here. Or the t values here, right? Our t's are our x's. So x2 is 60 and x1 is 0. So we're going to have to find the values at 60 and 0. For at 0, we know it is minus. It's going to be 500 for the output at t of 0 is 500. And 60, it says to the nearest tenth. We just averaged here, so we're going to check 60 again. The value at 60. So 125.78. All right, so this is going to be 125.78. All right, and you're going to get something like negative 6.2 grams per year, right? 600. All right, so about 6.2 grams are decaying per year. So explain what this means in this given context. So you can say something like this. The mass of the element decreases by an average of 6.2 grams per year between the 0th and 60th year. I don't know what happened here. I'm going to rewrite this part neatly. Per year between. All right, so that's that whole thing. All right, let's take a look at the next problem. August 25th, All right. The height in feet of the tides along the coastlines can be measured with the water levels oscillating between the low and high tide. The graph below shows the height of the tides y equals bt in feet in Daytona Beach after midnight on a day in July. All right, so this is a trig function, like it's a wave, right? So let's see what the question is asking. State the period bt in hours. So the period, right, I can see that this is, it starts, seems like it's the middle of the graph is somewhere around here, right? And it's not starting in the middle, so it's not a sine function, right? It's starting at the top or the bottom. It's starting at the bottom, so some sort of negative cosine function, right? And if it's starting at the bottom, all right, that means I have to look at the bottom and see when it hits the bottom again to find one period, right? So that seems like it takes 12 hours, right? So my period is 12 hours, right? It's just 12 hours, not 12 pi hours, right? The pi doesn't have to be there, all right? Now it says write an equation for bt in the form a cosine bt plus c. All right, so let's break this down, all right? So let's find our a here. Our amplitude is the max minus min divided by 2, all right? And that's going to be 5 minus 0 divided by 2. It's going to be 2.5, all right? My b here, to find my b value, remember, we have to use our period to find b. So period equals 2 pi over b. Period is 12, so 12 is going to be 2 pi over b. All right, I'm going to get b12 equals 2 pi. So b is going to equal 2 pi over 12. And if you reduce that, it's pi over 6. So b is pi over 6. All right, and now we have to find the middle of the graph, or the vertical shift. And c is going to be the maximum plus the minimum divided by 2. So that's just going to be 5 plus 0, right? 5 is the max, 0 is the min, divided by 2, which is just going to be 2.5. All right. So again, the amplitude is, the formula for the amplitude is the maximum minus the minimum, right? So max of the graph is 5 minus 0, which is the minimum, divided by 2, and that'll give you a, the amplitude. All right. So now we have everything to write the equation. Remember, we decided earlier, because it doesn't start at the middle, it's a cosine graph, right? If it started in the middle, it would be a sine graph. And because it starts at the bottom, usually cosine graphs start at the top, the maximum. But because it starts at the minimum, we realize it's a negative cosine graph. So we have b of t equals negative, because it's a negative cosine function, negative 2.5 cosine pi of 6 t plus 2.5. Right, so that is my whole thing. All right. In Derby, Australia, the height of the tide in feet can be modeled by the function dt equals 8 cosine pi over 6 plus 16.5. On the grid provided on the previous page, right? Graph y equals dt on the domain 0, between 0 and 24. All right, so let's graph this. Now, we have almost all the information we need, right? So this is already indented for us. The middle of the graph, the vertical shift, is 16.5. So I'm gonna, let's do something else. Now I'm gonna rewrite the function. 8 cosine pi of 6t plus 16.5. And that's d of t. All right. All right. So the middle of the graph is 16.5, right? So now we have to find the maximum and the minimum, right? And we have to find our period to see how one whole function will take. So the maximum of d of t, so this is the work for d of t, max equals k plus c, max equals c plus a, and c is 16.5, and a is 8, that's 24.5, min equals c minus a, which is 16.5 minus 8, which is 8.5. And my period is 2 pi over b. So my b is pi over 6, so period equals 2 pi divided by pi over 6. And that means my period is 12, because we already did this calculation earlier from the previous problem. It's the exact same, right? So my period is going to be 12. And now, remember my interval is just going to be my period times 1 over 4. So I'm going to find here 12 times 1 over 4 equals 3. All right. So I'm going to indent every 3 here. Every 3. So 3, 6, 9, 12, 15, 18, 21, 24. And that'll let me know how to operate the graph. All right. This is a normal cosine function, so we know it starts at the maximum of the graph, which is 24.5. So the starting point is going to be here, 24.5. And at the next interval, it's going to go down to the midline, which is 16.5. And the next one is going to go all the way down to my minimum, which is 8.5. My next interval after the minimum, I go back to the midline, which is 16.5. And at 12, I'm at the end of the cycle, which is going back at the top, which is 24.5. And this cycle just kind of repeats itself over and over again. All right. All right, so this is going to be... All right, so that's going to be the function graphed properly. All right, and you want to maybe label this as d of t. All right, because b of t is also labeled. All right, so that's the whole graph. State the height of the low tide. The low tide is the minimum. The low tide is the minimum. I know we already did the work up top, here below, but let's just do it again because you don't know how the grader is going to look at it. They might not look at the previous section. So the low tide, right, minimum equals c minus a, which is 16.5 minus 8, which is 8.5 feet, right? And that's my final answer. All right. So last problem, we're almost done. So last problem, January 26th. Problem 37. Xander and Yvette are each participating for their road test. Xander decides to drive for 15 minutes on the first day and plans to increase the amount of time he spends driving by 5 minutes by each day leading up to the day of his test. Yvette decides to drive for 10 minutes on the first day, and she plans to increase the amount of time she spends driving 15% each day leading up to the day of her test. State the plan for the amount of time per day that can be modeled by an arithmetic and whose plan can be modeled by a geometric sequence. Explain by a reasoning. All right, so let's break this down, right? So let's take a look at, Xander. Xander, he's going to drive for 15 minutes on the first day and increase the amount by 5 minutes each day. So that's a linear amount. It's going up by a certain amount each time. So Xander is an arithmetic sequence because it's not a ratio. We're not dealing with a percentage, right, or anything. It's just going up at the same rate every day. First day 15, second day 20, third day 25, so on and so forth. So we could write Xander's plan can be an arithmetic sequence because he increases his driving at the same rate each day. Okay. All right. So now, let's take a look at Yvette. 10 minutes first day. All right. And she plans to increase the amount 15%. So we're dealing with the percent. When you're dealing with a percent or a decay, or some sort of multiplier, right? And there's a ratio involved, that's a geometric sequence. So we can say Yvette's plan can be a geometric sequence because her time is being multiplied. How much is it being multiplied each day? Remember, in the purpose of this class, we start at 100%, and she's increasing 15% a day. So we could write this as 100% plus 15%, which is 115%, which when we're doing math with this would be 1.15 being multiplied by 1.15 each day. And for Xander, we could write 5 minutes, right? So I'm going to just fix this up. So 5 min each day. Let's be specific in our language so no one can take points off. All right. Write an equation for xn that represents driving on the nth day for Xander's plan, and equation yn that represents the amount of time driving on the nth day for Yvette's plan. All right, so let's break this down. We're going to have an equation xn, right? This is the geometric sequence formula, right? This is given to you on the regions, so you're just following the formulas on the regions. You're going to look at, and you're going to see arithmetic and geometric sequence here. Xander's is arithmetic, so you're going to start off, right, 15 each day plus, right, n minus 1 times 5, right? n minus 1 times 5. So because he's going on 5 each day. And your vet's plan, again, you get this in the region, so look at the formula. It's going to be 10 times 1.15, all right, to the n minus 1. Because we're starting at 10 minutes for your vet, multiplying by 1.15 each day, and we have to do n minus 1 because we don't count the first day, right? So the first day is already started counting, so that's why we subtract the first day. All right, so now it's asking who will spend more time driving on the 19th day of practice. Justify your answer. So you're going to find x of 19 and y of 19, all right? And you're just going to plug in 19 into where n is. So you can get 15 plus 19 minus 1 times 5. And for your vet, you're going to get 10, 1.15 to the 19 minus 1. And let's plug both of these in the calculator. All right. For Xander, you're going to get 105 minutes. And for your vet, you're going to get around 124 minutes, right? So who's spending more time driving on the 19th day? Well, your vet will spend more time, and you could write in parentheses about 19 mins on the 19th day. All right, so that's all the questions. Best of luck. And if you need any help, you can always ask me, right? So, yeah.